Welcome back, everyone. We will now hear from Dave Repsher, his wife Amanda, and Karen Mahaney via video. They're going to tell you about their lives before and after a helicopter crash. Dave is a survivor of the crash that included a post-crash fire. Karen's husband, Patrick, was the pilot. As they each tell their story, you'll hear about the FAA's regulations that address occupant protection features for rotorcraft. For those in the audience who are less familiar with those topics, here's a brief background. In 1989, more stringent regulations for occupant protection on rotorcraft went into effect for rotorcraft seats and structure, and in 1994 for crash-resistant fuel systems. However, the regulations only applied to new rotorcraft designs. This meant that newly manufactured rotorcraft were not required to meet the regulations if they were not new designs. Unfortunately, most of the newly manufactured rotorcraft from the time the regulations went into effect up to the present day were not new designs, so most did not have to meet the more stringent FAA requirements. The helicopter Dave was on and Karen's husband Patrick was piloting on that day of the accident was one of those cases. Karen will discuss an effort she led related to requiring crash-resistant fuel systems on all newly manufactured helicopters built after April 5th of 2020, regardless of whether or not it is new design. In addition, you will hear our speakers refer to some helicopters as the legacy fleet. They make up the majority of helicopters flying in the US today. These are helicopters that are either already flying when the regulations went into effect decades ago, or those that have been built since that time, but were not required to meet the more stringent regulations. This is because the regulations from 1989 and 1984 did not set a future date that required all helicopters in the US to either retrofit or cease flying if they did not meet the more stringent occupant protection standards. The combination of all these factors have resulted in only part of the US helicopter fleet meeting the higher safety levels of occupant protection for seats, structure, and fuel systems. I hope this background helps you as you hear the stories of Dave, Amanda, and Karen. Thank you.
Hi, my name is Lon Head. I'm an editor with Vertical Magazine, and I'm so honored to be here today, joining for this conversation with some really amazing people. So I've been writing about the helicopter industry for about 15 years now and writing about helicopter safety for most of that time as well. And I don't think anyone I've met during that time has had as great of an impact on helicopter safety as the people you'll be talking to and hearing from today. So with that, let's do some introductions. And Crystal, I'll hand it over to you.
Great, Elon. Thank you so much. My name is Krista Haugen. I'm the co-founder of the Survivors Network for the aeronautical community. And I agree, Elon, it is a great honor to be here and a privilege to be with some of the most inspirational people I've met and consider survivors in the industry. And I've watched their journey and watched their efforts ever since their experience unfolded, and it has been nothing short of amazing. So it is absolutely an honor to be here.
My name is Karen Mahaney. I have been an RN since 1992, so almost 30 years, going 30 years now. I was a flight nurse for 7 years and flew with Flight for Life. And there I met and fell in love with Patrick Mahaney, my husband, who is a Flight for Life pilot. And I today still continue to work as an RN. I've got my master's in anesthesia. I'm a nurse anesthetist in the Denver metro area.
My name is Amanda Repsher. I want to thank everybody who's tuning in today, and thank you for this opportunity. Also wanted to mention that we are doing this under social distancing. You saw us removing our masks. We're in the beautiful outdoors today. I am a critical care nurse and a former paramedic, and at the time of Dave's helicopter crash, I was working as an administrative nurse. Very happy to have this opportunity here today.
Hello, my name is David Repsher. I'm a crash survivor from 2015. An air ambulance crash in Frisco, Colorado. I was a certified flight nurse and national registered paramedic, and suffered burns on 90% of my body. And we're very excited and thankful to have this opportunity to speak to everyone today.
So Karen, July 3rd, 2015, a very significant day. Can you tell us a little bit about where you were and how that day's events unfolded for you?
That day, July 3rd, 2015, was Patrick's normal scheduled shift. He worked 6 on, 6 off. He'd been a Flight for Life pilot for 27 years. And I wasn't supposed to be off that day. I was originally scheduled to, with my anesthesia job, to be working down in Denver, which is 70 miles away. As circumstances would have it, I was in Summit County, just minutes away from where the helicopter went down. I was seated, waiting outside a restaurant, waiting to go in and be seated for lunch, and I heard the sirens of the fire department wind up, and I thought that was unusual, but then I thought, well, it's the holiday weekend, maybe someone had just crashed their bike. And then the phone rang, and the person on the other side said the helicopter had crashed and I needed to hurry. And I got in my truck and I drove literally 100 miles an hour to get to the hospital. It was about 10 minutes away. And when I pulled up, the aircraft was fully engulfed in flames and black smoke. And I got out and I ran into the emergency department. And I went into Patrick's room and they were just starting CPR on him. And he was modeled from the chest line up. They had just placed a breathing tube, and I ran up to his ear and I told him that, I'm here, honey. And please come back to me. Please don't leave me. And then the doctors and nurses vented his chest. They heard a whoosh of air. He had had a tension pneumothorax, and they got a pulse back. And so I went to the other side of the bed and knelt down and just started talking to him continuously, letting him know I was there. And I started to thank him and to thank him for loving me and for choosing me and for being the most amazing husband. We had a good pulse for maybe about an hour. He was receiving rapid blood infusion, and the doctors were prepping him in the preparation to fly him to Denver via another helicopter. And his pulse became weaker and weaker. And I knew, having been a critical care nurse for almost 30 years, I knew the signs were ominous at that point. And so I made sure that I held his hand and I kept continuing to talk to him to let him know I was there and that I loved him. And at 74 minutes after the crash, and they were doing CPR again, and he was flatlined. And I said, he's gone, and the doctors agreed that he was gone. And I told him I would be okay. I told him I would be okay and that I loved him.
So, Amanda, where were you on the day of the accident, and how did the events of that day unfold for you?
On July 3rd, 2015, this is still emotional to talk about, and it's not because of where we're at today. We're very blessed and very grateful for where we're at, but it's hard to talk about that day. We had just gotten back from the most incredible river vacation up in Idaho on the Middle Fork, and I wasn't scheduled to go back to work. This was a Friday. So I got a phone call I had just gotten back from the gym and made myself a sandwich. I was sitting down to eat, and our good friend George called. And what he didn't tell me, I found out later, was that he already knew it was the Flight for Life helicopter, but he knew I was alone. So he said to me, Amanda, I heard there was a helicopter crash in Frisco, but that everybody walked away. And I started to panic, and in my brain I thought, there's helicopters that fly over the county all the time. It's not just Flight for Life. It can't possibly be Dave. And I called his cell phone, and there was no answer, which wasn't unusual because he didn't always carry his phone with him at work. So I left a message and thought, well, geez, tonight we'll kind of talk about how panicked my message was on his phone when he gets home. And I picked up, I went to go sit I called the dispatch line for the nurse's office, and there was no answer. And again, I thought, well, that's not unusual. And I was sitting down at the computer to look up the central dispatch number to call flights. And my phone rang. And I saw the caller ID. It was our good friend TR, who works at the hospital. And I picked up the phone, and I said, you tell me now what? And he said, he's alive. We're intubating him right now. Get to the hospital as fast as you can. And I felt like my heart fell out of my body. I couldn't breathe. And I asked if anybody had called Dave's mom yet. They said no. And I said, I'll call her. They just had gotten back from a hike, his mom and stepdad, which they had just been out of cell phone service. And she picked up the phone, and I said, the helicopter crashed. He's alive. Get to the house now. And when we got to the hospital, I ran inside into Dave's room, and I took one look at him, and complete despair just fell over me. Being a critical care nurse, I had worked at the hospital that Dave was about to go to, and I worked in the ER, and I'd seen 90% burns when they came in, and I knew what they looked like. And I knew how bad he was. And I looked at his hands, and they were just dead. And I looked at his face, and I saw the black, the soot. And I just thought, he can't leave me. This can't be happening. And when it came time to load Dave into the helicopter, the winds were whipping and the rain had started. And the chief flight nurse was hugging me, and we were putting him into the helicopter. And I thought, are we really putting him back in another helicopter? And the irony of that is that it was the only way he was going to live. Dave was truly one of those situations where those minutes matter, and saved his life. And so put him in the helicopter, and I had seen Matt being taken away, the other nurse. And I came into the ER, and I needed to see Patrick. I didn't know at that point that he was dead. And I opened the door to his room, and Karen was standing over him. And we hugged each other, and we were just both crying. And she said, Amanda, I don't know how I'm gonna live without him. And I said, I know, and I'm sorry. And I thought the whole time, this is gonna be me. And I came out and just collapsed. So we needed to get to Denver quickly, and Dave's stepdad drove. As I was saying goodbye to Turk, our dog, I was hugging him, and I was just crying. And I said, buddy, I don't know when I'm gonna see you again. And the whole time I was thinking, I hope it's not tonight, because if it's tonight, it means that Daddy's gone. And there are moments of that day that are so clear in my mind that I can tell you every sound, every smell, every word. There's other times where it's blank, I don't remember. I remember getting to University Hospital. Dave was already in the burn intensive care unit. He was in what they call the tub room. And he was so critical when they got there. He was on death's door. They were doing everything they could to save his life. He had lost pulses in his extremities, and they had done the emergency intervention, slicing him open to relieve all the swelling. And the charge nurse said, Amanda, he's in the tub room, we're working on him, and we don't let family back there. And I said, I have to be with him. I was terrified he was going to die at any moment, and I didn't want him to die alone. I wanted him to know that I was there and how much I love him. And I said, I've worked here before, I've taken care of burn patients, and I've seen him. I can handle this. And so they let me back in the room. And they were all working so hard. And he came in when it was the day shift nurses. And then they transitioned over to the night shift nurses. And one of the day shift nurses was standing at the doorway to the tub room to say goodbye to me. And tears were streaming down her face. And I knew she was saying goodbye to Dave. And nobody thought Dave would make it through that night. But he did.
So Dave, on July 3rd, 2015, your life changed in an unimaginable way. Can you tell us about the events leading up to the accident and how things unfolded from there?
Well, it was just a day at work, from what I remember. It was a beautiful day, clear skies. We had a public relation event scheduled. I like to call them a touch-a-truck day. We were flying over to a Boy Scout camp and going to meet up with a bunch of other first responders over there and have a little show and tell. And there was no pressure. There wasn't a medical call or a trauma or anything. It was just a flight over the mountains, and we were looking forward to it. It's always a beautiful flight. And not to suggest complacency by any means. We all had our role. We always took everything very seriously, and it was just a day at work. No red flags. Everyone was healthy. Everyone was feeling good, and so we were out in the helicopter, and from that point, my memory honestly is still pretty spotty. But I just remember at some point during the takeoff, something went wrong, and I didn't know what it was. We don't recall hearing anything, feeling anything strange, but just knew something was wrong. And I looked over at my partner, and we looked at each other and got on the intercom and asked Patrick if we were okay. And we didn't get a response, and we cinched down our seatbelts and off we went. I remember an impact. I didn't think I got knocked out, but I probably did. And really my first recollection after the impact is one that sticks with me today. Is I just felt like a giant rush of cold liquid come over my shoulders. And I describe it to people as if you remember that ice bucket challenge from a few years back, or the coach getting, a bucket of Gatorade dropped over him at the end of a game is how I describe it. And then there was fire. And I didn't really know what was going on. I just knew I had to get out. And I didn't know where I was. I just tried to get out. And there's fire all around, and I just kept trying to get away from the fire, but as it turns out, I was the fire. And every direction I went, I just kept feeling the fire and taking in smoke and breathing the fire. And I heard this voice for me to get down on the ground and roll. And here's a poor guy on his bike, on a bike path next to the hospital and enjoying a beautiful day. And all of a sudden he's confronted with me, and I get down, I roll down to the path and just following his voice, and he's sitting there throwing dirt, as much dirt as he could find on me to try to get the flames out. Eventually the paramedics came from the ambulance and put me on a backboard, and they were running me into the emergency room, which is a couple hundred yards away, and I started giving out orders. I'd taken in a lot of smoke and fire, so I told them they were going to have to intubate me, and I just remember how hard they were working to get me into the ER, and I got in there, and that's really when I first started feeling things, I think. And I just had my hands up. I don't know why, but I had my hands up, just holding them up, and I could just see the skin sloughing off my hands. And they were having a hard time finding an IV on me. And I was giving out medication orders and anything I could think of, and I was telling them to grab the interosseous needle. And they finally got a line, and right before they gave me the medication to sedate me, I didn't know. I knew I was in bad shape. I didn't know how things were going to go. And I just looked up at one of the nurses and said, "Tell Amanda I love her." And then it went black for 5.5 months.
So this is a question for all three of you. All of you had been working in or around the helicopter air ambulance industry for quite some time. How much did you know about helicopter crash safety before the accident? And what was your impression of the helicopters you were flying in? Did you think they were safe?
The program that I eventually went to work with, our regional program, had a fatal crash back in the early 90s. And, I went into this job with my eyes open, but as Amanda and I used to say, I felt much safer going to work on the helicopter statistically, at least, and I did feel safe rather than being on the ambulance. The program I worked for, I had 100% confidence or more in all of our pilots. They were very experienced, and the program I felt took safety serious in every sense.
One of the paramedics who trained me on my paramedic internship in Las Vegas was killed in an air medical crash outside of Las Vegas. And I remember going to her funeral, and I was so impacted by that, and I thought, I can't ever do this. I can't ever assume that kind of risk. It's just too risky. When I learned that Dave wanted to become a flight nurse, I had quite a bit of angst about that. I also knew it was his passion and his dream job, and I supported him 100% in that journey. And he loved that job, and he was amazing at it. And I felt comfort knowing that he worked for a company that I felt was one of the safest ones out there. And to me, safety had to do with the company, the training, the pilot, and their culture. It never occurred to me that safety had to do with parts of the helicopter and manufacturing and regulations.
But I have to say, in reflection, in my heart of hearts, I never thought Patrick would die in a helicopter crash, because I thought that it went, crash happens, NTSB investigates, NTSB makes recommendations to the FAA, and the FAA looks at them and says, absolutely, we're going to do that. We're going to enact that. And I thought that was exactly what happened. And so then with finding out about this loophole, and that the NTSB had been going over and over for almost 25, 30 years, making recommendations about the safety measures being placed on the aircraft. When I found out about that, all I could say is I didn't know what I didn't know. As a crew member, as the spouse of a pilot, I didn't know. And in talking with Dave and Amanda, they both say the same thing over and over. We didn't know what we didn't know. And when we go to talk to crews, when we have talked to groups of pilots, it's the same reaction. People don't fully know what they have and don't have on their aircraft because they're being told it's the safest available aircraft out there. Well, there's a loophole, and it's not being manufactured because they don't have to.
This question's for Amanda. Amanda, once the initial shock wore off and you began to understand that this was a known problem with known solutions. It had been identified and rectified in the military years earlier. And you're there in the ICU with Dave, you know, in this unfathomable condition because of what is a preventable issue. How did you process that? And then what, if anything, has changed regarding the way you think about it between then and now? And I would ask the same question of Dave when you woke up.
That's an excellent question. Obviously, while Dave was so critically ill in the ICU, my thoughts and my emotions and everything were focused on him. I was told about the fuel system rupturing, and it was hard to process at first. It was very confusing, and I didn't fully understand the issue other than what I was being told. And knowing that Dave was in the hospital because he was burned, and he literally would have walked away from the crash. He had 1 rib fracture and 4 transverse process fractures. He probably wouldn't even have spent a night in the hospital. So I knew that he was there because of the burns. And then to hear that the fuel tanks ruptured and that there was technology out there in the military that could have prevented that was very, it was hard to hear. And I remember sitting at the conference table in the burn ICU, sitting with the legal team and saying to them, this can't happen again. If this was preventable, this has to stop. Nobody else needs to go through what we're going through. And they said to me, one case isn't going to change the industry, Amanda. You need to know that going into this. And I thought, we have to try. We have to make this stop.
Really, from the moment I woke up, and then throughout my whole recovery, it's, I think one of the biggest things that we wanted to focus on was to ensure that we did our part to not allow this to happen to anyone else. And the pain and the suffering, the toll that it's taken on us, all 3 of us, and the community as well, that no one deserves to go through this. It is preventable, and that's our mission going forward, and it's hopefully gaining more and more traction.
So at the time the accident happened, I had already been flying helicopters for over a decade, basically. And I had, like many pilots, kind of bought into this idea that had been put forward by the industry and manufacturers that it simply wasn't practical to make many of these, crash safety improvements on legacy models. So when this accident occurred and when you started advocating for safer helicopters, I had to undergo a bit of an awakening and a mental shift myself, and realizing that, hey, maybe what I had taken for granted for so long, I really shouldn't have. And, this status quo isn't acceptable. So when you started speaking out, what type of reception did you encounter from the helicopter industry? And how have you seen attitudes change over the past 5 years? And I would say that's a question for all of you.
I went to Washington, D.C. the first time in May of 2016. So the crash happened in July 2015, and in May, Patrick was being inducted into the National EMS Memorial. And so I asked Patrick's company, Air Methods, and they opted very kindly to help me with a few lobbyists to help me open some doors. And I went to Washington, D.C., and I talked to multiple congressmen. But last second, I got a meeting with Senator John McCain. And Senator McCain was a Vietnam-era pilot. I went in there and in 5 to 10 minutes was able to communicate to Senator McCain what had happened. And he was leaning forward through that meeting, and he leaned back and he said, "This isn't right. I'm telling you what you're gonna do and how you get this changed." He said, in Washington, he said, you go home, you write down what needs to happen. He said, you go to your Colorado delegation, meaning both the senators and the representatives on a bipartisan level. He said, you get that delegation to bring this forward as legislation. That's how you get things done in Congress. And from that moment on, those have been the footsteps that I've followed, the footsteps that Senator McCain's put down for me. And that is how we got the very first piece of helicopter safety legislation ever in the United States passed in October of 2018, the mandate for crash-resistant fuel systems.
It was our priority and our commitment to make change and to be part of that change and to save people and not have people go through what we've gone through. And we didn't know how that was going to be received when we started going to these events. And it's been truly amazing. There are so many good people out there in this associated with the rotorcraft industry in every aspect who want to do the right thing, want to make change, want to make everything safer. And it's wonderful when you see that.
I think this question is for everybody. I'd like to start with Dave. The process to institute regulatory changes in matters like this typically begins with a cost-benefit analysis. While we understand the need to look at the economics of sweeping changes, how do you calculate the benefit of preventing what happened to you? And does it go just beyond numbers?
There's obviously a humanitarian aspect to this, is that there's a lot of things that survivors go through that can't be summarized by numbers or specific benefits, and the things that you go through, and not just yourself but your family and community and friends all play a role in it, and there's all a cost, so to speak, to that as well. Not only is it the loss of income, loss of companionship, loss of careers, but it affects the companies and the operators as well. As how do they replace the aircraft, and what happens to the staff, the remaining staff, and their morale, and what about the psychological health of not only the survivors but the community, your family and friends, and also that's what's left at the operation as well. And how do you assign a number to that?
So I think Dave's point is very well taken, that there are so many costs that don't have a dollar sign assigned to them. But currently there are a lot of costs with dollar signs that are not being captured. So that's something to be addressed going forward. And that's something I think we're all going to have to partner with. How do we figure this out? How do we create a cost-benefit analysis that actually captures real costs and the costs that you don't necessarily see right up front?
So as Karen has observed, the military has been focusing on crash safety in helicopters for quite some time. This is a question for any of you. Why do you think the civil helicopter industry has been so slow to make crash safety improvements? And what do you think would help accelerate the pace of change?
I'll go. I think just to set a base, I think the military recognized early on that their most valuable asset were the occupants within the helicopter, and they were quick to develop crash-resistant fuel systems and seating and structure to enhance their survivability. They know what it takes to train and recruit pilots and the infantry, and the crossing over into the civilian world. It's really I feel a different animal. Your missions are different. There's a vast array of different operations, certifications, and regulations. And honestly, I think a lot of it comes down to the money. If you're a small operator and your margins may be thin to begin with, it's really hard to put extra money out into into safety features. And another big issue that is that there's been a very soft insurance market for the civilian world as well. And so there hasn't been a lot of price pressure.
I have a way of describing what I think is the current situation in the civilian world. It's like a three-legged stool. And if you don't have all three legs intact, the stool is going to collapse. So first one is the stick. That's the regulatory piece. And the second leg is the carrot. That's the economic piece. And the third leg is what I say is the consumer demand. So you really need to have all three. There has to be the mandates that things have to happen. It has to be economically feasible for it to happen and to make it easier to happen. And the consumer needs to demand that it happen.
Dave and Amanda, what's your desired end state with regard to your efforts? What would you ideally like to see happen?
I'd like to never, ever see anybody go through what Dave went through. To be burned is, he experienced pain that no human being should ever go through. And to watch what he had to go through, it's hard to explain. It's hard to describe. He's the strongest person I've ever known. I think that most people can say they've ever known that he could survive that, but being burned affects every organ of your body. He took him 6 months to learn to walk again, 6 months to learn how to swallow again. And again, to know that he would have walked away from that crash if it weren't for the burns. I think that now that with the efforts of Karen and all of the legislators who worked on it going forward, newly built ships will have the crash-resistant fuel system. For me personally, I really want to see the legacy fleet get retrofitted and work hard towards that goal.
I think, like everyone in the industry, I think, the best crash is the one that doesn't happen. And, the industry does really, I've seen the change of, just in my short time with this, is seeing the emphasis on implementing safety protocols and management systems before a crash ever happens. And, as much of a dream as that is, will we ever reach zero? Probably it's not likely. And so I think we should give every crew and every occupant the fighting chance that they need to survive. And there will be crashes that are not survivable. But for those that are, everyone deserves a chance. And I think the legacy fleet that's out there, regardless if you're Part 91, 135, 121, whatever it is, everyone should have that benefit of being able to at least have a fighting chance to get out. And part of that is closing the one last loophole that's out there, and that's with seating and structure. And that's going to be, a journey in itself, but it's shown through the work that Karen did that change can happen legislatively, but hopefully the industry takes it on themselves to make those changes.
So this is a question for any of you, and I would say that your willingness to speak out and also to expose yourself to public scrutiny has been a big part of why this longstanding safety issue has finally gotten the attention it deserves. What has that process been like, and what advice would you have for other crash survivors who might feel compelled to become advocates or who, might not feel able to at this point?
So when Dave was in the hospital, the medical staff would talk to me and say, well, when he makes it, when he pulls through, when he gets on the other side of this, he can be a motivational speaker. And I said, well, you don't know Dave. He's a very private person, and no, he's not going to do that. So it's been a journey for us to open up our personal lives to the public. But there's been a lot of rewards from that too. I mean, we've met incredible people. We've gone to great places. Every time we share our story, it helps us heal, and we hope it helps with change as well.
And I really felt like being married to Patrick walking this journey with him, and then finding out and that being essentially handed the baton, and I could almost feel his spirit saying, run with it, honey, you need to go. This is what you need to do to change, because he was, like I had mentioned before, he was the pilot he was a pilot's pilot. He was willing to do whatever it took to help his fellow pilots. And it has been a journey for me of healing, of unbelievable friendships, and of something that I never could have expected. It's very lonely. Being a widow is an unbelievably lonely path to walk. But it's made me stronger. I found strength in places in my life and in my heart that I never knew that were even possible.
On a related note, and this is for all of you, resilience is really a big topic in EMS and aeromedical these days, well, and everywhere these days, considering the current circumstances. But you three are some of the most resilient people I've ever met. How have you built and maintained that resilience? We'll start with you, Dave.
I tried to find an outlet, and for me, luckily, it was exercise, and I love being outside. So after shifts or before my shifts, I'd go play hockey, do whatever I could, and that really helped me mentally kind of reset. And throughout this whole process after the crash, I really got a lot of my resilience, I think, from Amanda. Right after I woke up, she really set the tone, which I'm, grateful for. So, I just remember I think the most important thing I could hear was, don't get angry. So I just kept looking forward to the next day. And for whatever reason, I was able to kind of set my situation aside a little bit and not dwell on things. And I don't know how I did it. I really don't. But I just wouldn't dwell on the situation I was in, and I just keep looking forward to things that were coming up, and knowing that there were some really bad days, but there'd also be some good days as well.
Dave is my rock. He has been always, and I've always keyed off of him, drawn strength through him. And I didn't get through this alone. I've had an army of loved ones supporting me, and I drew from that as well as drawing from Dave's strength. And I had a sticky note on my computer that I would look at every day, and it said, "You don't know how strong you are until you have to be that strong." And you dig deep and you find strength that you don't know that you have. And as Dave said with the anger, for me, anger, if you give into the anger, it'll consume you. And if you are angry about something that happened, if we were angry about this crash, then the rest of our lives, how would we be happy? We would let that control the rest of our lives. And we have had this path set in front of us, and we choose to walk it with looking forward and focusing on positives and our love. Really, I mean, it's when you're blessed to have that kind of love, it's a very special gift.
Being a widow is a very lonely path. You have people around you, but you're missing your soulmate. You're missing the person who walked hand in hand with you in the very public moments and the very private moments, and you miss them every second. And I would say that I can't speak. Every death, every situation, every trauma is different. But if I'm going to generalize, I would say there's a lot of anger and sadness and hurt that happens when you lose somebody, when they die. And it was easy to slip into this was done to me, either that God was doing this to me or other people did this to me. But when you back away from that and you go, nobody did this to me intentionally. This was not done. This is how the universe chose for this to happen. What can I do to make the situation better? Then I was able to put myself more at a distance from the situation and look at the people on the other side and reach across the aisle and find the friends over there. And they came closer to me and I came closer to them, and we're finding a solution. And it makes me really believe in who we are as people, things that we can change, things that you can essentially say 10 years ago that our party and another group would have been at polar opposites, but now we have friends throughout the industry.
So one of the attitudes that the helicopter industry has had for a long time is, well, you only need crash safety features if you crash, and I'm not going to crash. So what would you say to people, who maintain that crashes are rare events, and so investment in crash safety features isn't worth the expense?
It doesn't matter if you're the biggest operation, the smaller operation, the best funded operation, the best safety organization. It doesn't matter. It can happen to anyone at any time. And the expense of not doing it is it affects not just yourself, but the industry as a whole. And insurance rates climb. So not just for you, but for the rest of the industry as well. And the public relations matters. Once again, the helicopter industry is being spotlighted not for doing something good, which it so frequently does, but for having fatal crashes and injuries.
I equate a helicopter crash, an incident, like taking a hammer to a glass coffee table and taking the hammer to the center of it. Yes, you're going to have the impact and the devastation in the middle, but there's the splintering and the fracturing that happens, and it goes and goes and goes, and it's not a measurable piece of information. It's human cost, and the community, the program, the friends, the family, the people that I've met who just heard about it and live in the Denver metro area and say, I'll never get in a helicopter. And I'll say, oh, I don't want you to say that. Those are some of the consequences that I think if you have your ears closed off and you say it's only us having to replace that aircraft and that, dealing with the crew that were injured or died, that's not being truthful of the whole situation.
I would say to everybody that you're being naive. Helicopters crash, and we want to make them be as survivable when they do crash and as safe as they can be. But when you get into a helicopter, you are taking a risk. And as somebody running a company, for whatever reason, if it's for air medical or it's for search and rescue or police or utility or tourism, you have a responsibility to every single person that gets into that ship to protect them to the best that you can. And if you think that it's never going to happen to you, then that's just completely naive and it's negligent.
This question is for all of you. What can people watching this do to help?
And so I would say first and foremost, just finding out, being educated about the different aircraft and the different possibilities. And then, our future goal, and when I originally went to Washington, D.C., I took with me a tax credit because, again, I'm realizing that I love this industry and I understand it's a business. And so you can't just mandate every single thing to the nth degree. And so you have to put a carrot out there. And so having a tax credit that would incentivize it and make people want to do that, want to be safer, is something. And so I would say reaching out to your congressman and saying, and your senators, and saying, this is what matters to me. And this is very important to our business. This is very important to our family, because as part of what Amanda had said with the three-legged stool, putting a carrot out there, but also the public having an input to either their legislators or the companies is a game changer, is an absolute game changer. When people say, this is what I want, then that's what happens.
I would say see where you fit in to the three-legged stool and do your part. Are you part of the change that's going to come with the regulatory piece? Are you part of the change that could come from the economic incentives? Or are you part of the consumer demand? And figure out what your role is and do your part.
Again, I'd like to highlight, just get informed. Go out to the hangar, go out to your aircraft, see what's in there, ask questions. And, you know, the biggest way one of the easiest ways that this can change is if there's a demand.
Thank you so much to the three of you for your grace, for sharing your wisdom and your insight, and really also giving a voice to the voiceless in this incredibly difficult but important conversation. So you've shared lessons that are relevant to all of us, and I definitely thank you for the opportunity to be with you today.
I would like to echo Krista's thanks. Again, you all are really an inspiration. And the reason why I think you've had such a profound impact on the helicopter industry is you've encouraged all of us to, question the status quo and what we had taken for granted, and opened our eyes to the way that things could be. And I hope that going forward, we take that momentum and we keep moving forward to make the industry better and safer for everyone.
With us now are Dave and Amanda Repsher and Karen Mahaney. Dave, Amanda, Karen, thank you for your willingness to share the journey you've all been on for the past 5 years. It's also inspiring to hear each of your stories. You took this incredibly painful and tragic event and elected to rise above the worst of circumstances. You used it to educate and inform others, advocate for higher levels of safety across the helicopter community, and make meaningful long-term safety improvements in our industry. Thank you for being here with us today. And now I'd like to ask conference participants, if you have questions, please submit using the Q&A button on your screen. And Dave, Amanda, and Karen, I'll be relaying the questions to you. Give it a couple seconds here. Hey, I got a question for Karen. How you doing, Karen?
I'm good. Thank you for having me.
Thank you for being here. It's our pleasure to have you here. Question I have for you that came up. You had mentioned the tax credit legislative proposal that would incentivize retrofitting the legacy helicopters that do not have the big three crashworthy fuel systems, crashworthy fuel systems, energy attenuating seats, restraints, and crashworthy structure. Can you explain this legislative idea and tell us where that legislative proposal stands right now with Congress in DC?
Absolutely. So I know we have a limited time with question and answer, so I'll try to be pretty streamlined with my answer. But so how we got here was about 6 weeks after the crash, the NTSB interviews the widow. And so in that interview, the NTSB let me know that had that aircraft had the structure, seating, and fuel system, which I have named the big three, that Patrick most likely would have survived the crash and been sitting there instead of me talking about the crash. And so that threw me on a trajectory of trying to help rectify that. And as the director said earlier, that 90% of people in crashes die from blunt force trauma, and Patrick was one of those. He died primarily from blunt force trauma. He essentially bled to death in front of me, but he did have inhalation burns as well. So he was affected by all three of those, of the big three. And so in just background, when I went to Washington, DC, one of my brothers went with me, and he has a background in renewable energy. And so he has seen the progression of the renewable energy industry go from where people said, you can't do it, this is impossible. And then the government threw out a tax credit about 15 to 20 years ago. And they put that carrot out there. And then all of a sudden, our nation, innovation nation happened. And the people that maybe their voices were not being listened to initially, they started to come up with amazing ideas. And now today we can go into a Home Depot and you can put renewable energy on your house. So that's how far we've come in just a short amount of time. And so when this accident first happened, people were telling me, oh, those things can't happen. They're too heavy. You can't put them on an aircraft. It's impossible. And so with the tax credit idea of it, it would be a 30% tax credit. And my initial idea was both for new aircraft and legacy aircraft. A new aircraft would get 30% tax credit when you purchase it. And that would, if the aircraft had the big three, structure, seating, and fuel system. And then, Patrick always said I was the pushiest flight nurse he ever met. So I wanted all for the crews. And so also including TAWS system and both fire and crash resistant camera system. But if that aircraft had that on there, purchasing that aircraft, you would have a 30% tax credit. So essentially you would have two aircraft A and B. Aircraft A is fully compliant, aircraft B is not, and that you would get it at almost 30% the price compared to the full price other one. And then for legacy aircraft, a 30% tax credit would be if those were retrofitted, you retrofitted structure, seating, or fuel system. Where that went is our two congressmen from Colorado, Ed Perlmutter, who sponsored the fuel system mandate legislation, and then Joe Neguse. They both sponsored our legislation in 2018, and it was a 10% tax credit, and it was just on the fuel system, but it made it as far as the Ways and Means Committee, and which is pretty amazing that it did. And so that's where the government starts to figure out, okay, how would we pay for this? And Dave and I both wrote letters requesting the chairman to give us a hearing on that. And then unfortunately, the pandemic happened. And so it kind of, our legislation fizzled. And what I've learned a lot about Washington, DC and Congress, but every time a new Congress starts up, then you have to reintroduce legislation. So we're hopeful that with this new Congress in January that we will be able to reintroduce this legislation. And I'm hoping that it would be even expanded maybe at a higher tax credit level and maybe to include all of the big three, and that we'll be able to move forward, because what that'll do is it'll put a carrot out there. And I really think it would take the aviation industry and turn it on its head in terms of safety, and things would just be happening that we could never even imagine.
I'm sure I hit my unmute button. Karen, a lot of information there, and it goes back to the story and what Amanda brought up about the three-legged stool. You have the carrot there. That's a good carrot to help keep that stool leg. Yeah, cool. Well, thank you. I have pretty much two questions, but maybe it could be melded into one, actually, for Dave. Being a flight nurse, both of them have to do with any area of safety precautions that can be taken. So I'll read both. One is how important you feel it is to wear PPE, such as helmets, flight suits. And the other one is, besides crash-worthy seats and fuel tanks, what other areas of safety would you like to see be improved to be, I guess, incorporated to improve survivability?
Well, thanks for having us, and this is a great honor. And to get to the second question first, I was ejected from the helicopter upon landing. I was still attached to the seat, and so I came out of the aircraft with the seat still on me and landed right into the pool of fuel. And so obviously incorporating that seating and structure as integral, just as important as crash-worthy fuel systems and any other safety feature out there. And so that's a big goal of ours to close that loophole, just as Karen did with the fuel systems. And we really hope we get some industry support, and I think we will. And as far as PPE, it's more than just a uniform. I hope people out there flying in whatever it is, fixed wing as well, is that what you're wearing can make a big difference in your survival. And for me, even though I was wearing a Nomex suit, I didn't have anything on underneath it. And so, in my case, it's a bit of an outlier. I was on fire for probably 3 minutes, but the places that I wasn't burned, I had some reference books in the pocket on my chest and my legs, and also a helmet. And so between saving my scalp and my underwear, a shout out to Hanes underwear if I can do that, cotton works, but between my those 4 areas, I was able to have enough skin to graft to cover my body. So it is vitally important that you wear a fire retardant suit, gloves, and a helmet at all times, cinch down, visor down, and I hope you take that to heart.
Thanks, Dave. Yeah, it's, as I say, before becoming a manager in the office now, I was a flight test engineer, and flight suits, helmets, gloves. It's articles we wore for flight tests. So it's definitely very important there. Thank you. I got another question, probably pertains to all three of you. Make Karen more specifically, but the move to get the retrofits, the crash resistant fuel systems and seats and structures, what timeline are you looking at of wanting to have that done? I know yesterday would be greater, back in 2015, perfect, but I guess, what are you striving for right now, or hoping Congress moves toward?
Well, I've Dave and I joke and say, and Amanda, and we say, I'll stay with this as long as it takes, and I may be 95 and, using my walker to get up to the steps of Congress to get it signed, or to whatever is being instituted. So we'll stay with it as long as it takes. And yeah, if it could have been in 2015, that would have meant the world to us, and Patrick would be here today. But we're hoping that with this new Congress, so starting in January, like I had mentioned, that every time there's a new Congress, you have to reintroduce legislation. It's basically whatever hasn't passed, it doesn't get to continue on, it has to be reintroduced. And so we're hoping that our congressman will reintroduce that for us, and even with an expanded scope than with what they, but the first introduction was groundbreaking. To my knowledge, there hasn't ever been an aviation tax credit legislation even proposed. So we're ecstatic about that. So we say sooner rather than later. So if anyone out there can lend us a hand at moving things forward, we would be so thankful.
I'd like to add, if I can, just real quick, that as Administrator Dixon pointed out this morning, it's going to take a collaboration from everyone. We're obviously trying to come at it from our side, and but the more industry values this, and insurance and consumer demand, we hope that the whole industry can come together on this, and each contribute in their own way, and all for the same goal, and that's to make it not only safer for the occupants, but have a thriving industry as well.
Well, thank you, all three of you. Thank you so very much for being here today. I'm glad we're able to make it happen. We've been talking, at least back in the office, with you and the accident investigators in my office. I know we had great communications there, and we're really glad we're able to get you on today and join your story with us. We really do appreciate it. Thank you.
Thank you for having us.
Thanks for having me.
Yes.
Thanks. Our next speaker is Dr. Kylie Key, an engineering research psychologist with the FAA Flight Deck Human Factors Research Laboratory within the FAA's Aerospace Human Factors Research Division. Her focus is computer-generated images as they relate to safety performance. Dr. Key, all to you.
Thank you, Stephen, for the introduction. And thank you all very much for the opportunity to present to you today. Can you all see the screen and me?
Yes, you can see.
Okay, great. So, as Stephen mentioned, I work at the CAMI Flight Deck Human Factors Research Branch, and we are responsible for conducting field and laboratory research about organizational and human factors aspects of aviation work environments. I have worked at CAMI for about 2.5 years now, and the research program that I am primarily responsible for is to investigate human factor considerations for the aviation maintenance environment. So today I'll describe a new research study that the FAA is conducting. We are investigating whether augmented reality displays of work instructions are feasible in the aviation maintenance environment and whether they might improve human performance. But before I dive into the augmented reality part of this, I want to provide some more context about maintenance to help you understand why a solution like augmented reality might be needed. I'm going to paraphrase the famous Dr. Reason and say, if we could design an environment that is ripe with human factor hazards, maintenance would be it. There are a variety of different tasks, from routine things like lubrication or fueling the aircraft to more complex things like an engine change or avionics. These tasks may occur inside a hangar or outdoors, so there may be challenges with lighting, extreme temperature, noise, and distraction. And maintenance operations frequently occur at night because that's when the aircraft are not being used. And the shifts are often long, 10 to 12 hours or even more than that. So technicians are often fatigued. And multiple maintenance tasks are happening simultaneously on the aircraft. And there's normally high time pressure to return the aircraft back to service as quickly as possible. All of these things make aircraft maintenance a complex job in and of themselves. But there's an additional human factor consideration that I want to emphasize today, and that is the written procedures for performing the work tasks. Every maintenance task has formal written documentation outlining the steps to complete that task. These instructions are in maintenance manuals and in work cards. Traditionally, they were paper, written-based instructions. And the problem is that deviations or non-compliances with these procedures frequently occur. And in fact, this is the top human factor challenge in aviation maintenance. It contributes to up to 70% of errors and accidents. So for the last few years, FAA CAMI researchers have been exploring why procedural non-compliance occurs and what the viable solutions or mitigations are for promoting better procedural compliance. And one frequently cited reason why non-compliance occurs is the procedures themselves. That's been documented all the way back to the 90s, but more recently in 2012. Next slide, please. So good technical documentation should be clear, correct, complete, concise, and consistent. Other best practices for procedure writing are that the procedures should be user-focused, they should be usability tested, and they should utilize user-friendly formats like checklists whenever possible. But these best practices and criteria are often not met in the aviation maintenance environment, which results in procedures not being followed. The main issue with technical documentation is how understandable and accessible the content is for technicians. Many research studies have documented the challenges with maintenance procedures. The procedures can often be confusing, and it can be difficult to comply with the instructions when they're located in multiple different printed manuals and digital media formats. Maintenance technicians can sometimes get lost in the large number of safety messages like warnings and cautions. And there are also linked references and other details. So technicians may have to navigate from one piece of documentation to another in order to get all of their information. So this can mean that sometimes they miss important safety critical information. And another issue is that sometimes errors are found in the procedures. And if an error is found, then it can be cumbersome to correct, and it doesn't always get fixed in a timely way. Furthermore, a written procedure or illustration may be missing in the manual, or sometimes there are conflicting instructions in the various documents for how to complete a task. So, for example, the job cards may say something different than the maintenance manual. Additionally, documents may not be available or readily accessible to mechanics, or may not have been properly validated or checked against task performance. And furthermore, one study showed that up to 43% of the technical manuals in industry have not been updated in a decade or more. Some organizations have to manage and update extensive documentation. For example, in 2008, Boeing had 5,500 active aircraft manuals with totaling 184 million pages. So the number of manuals and pages can make it difficult to keep these documents current. The bottom line here is that historically there are many different challenges with aircraft maintenance procedures. And because the procedures aren't very usable and they don't follow these best practice guidelines, technicians often don't comply with the procedures as written, but rather they find workarounds or shortcuts. And clearly this has negative implications for safety. As before, procedural compliance is the top human factor challenge in aviation maintenance, and it contributes to the majority of errors, incidents, and accidents across different databases we see like NTSB, NASA's ASRS, and so on. So the question then is, what can we do about it? Well, previous research suggested that one solution for promoting procedural compliance is to use better procedure writing, usability testing, and user-focused revisions. And it's definitely true that these are a step in the right direction. But as long as technicians are relying on paper documentation, it will be lengthy and not really that accessible or usable. Next slide, please. So, technology can help reduce the paper documentation burden and make the maintenance workflow better. There are many potential benefits of using technology to improve maintenance documentation. Research shows that when you digitize maintenance documents, it ensures that the information is available in a way that can more directly support the activity of technicians. It supports their workflow, specifically for administrative functions like sign-offs and feedback. And it can even provide automated reminders for tasks. And research shows that if you give automated reminders, it is an effective way of promoting procedural compliance. Finally, some technology allows for real-time communication with remote personnel and the ability to send photographs or videos for additional analysis by other team members. So this can be really beneficial for troubleshooting difficult problems, or for technicians who are relatively inexperienced, they can seek remote guidance from experts on their team. In recent years, many industry operators have transitioned to implementing these technological advances. And so now it's pretty common for maintenance procedures to be displayed using handheld digital devices like a tablet or a PDA. This does seem like a step in the right direction, but may not be fully effective because it's just presenting the same lengthy written instruction with 2D graphics. But instead of in a written paper-based way, now it's the same information just in a digital format. And next slide, please. So to take it a step further, maintenance procedures could be displayed in augmented reality. This has been done in other industrial settings like electrical engineering and spacecraft maintenance. And the aviation maintenance industry has begun implementing this technology too. For example, Boeing has designed and tested augmented reality instructions for wiring diagrams on a plane. And if it's possible, I'd like for us to watch their short video now. Could you click on the link? Thank you, I'm sorry. I'm sorry, it didn't have this difficulty when I tested it earlier.
Be sharing a separate screen. Okay, Kylie, the link isn't working, so you want to go on? Sorry.
Okay. Yeah, sure. I'm sorry about that little difficulty. Well, it's too bad because the video really is cool. So if it would be possible, then could we copy and paste it into the chat window maybe for other viewers to watch later? And then it's okay. I've prepared plenty of speaker notes to tell you what the video says anyway. So I'll just move forward and do that.
Okay.
So the video basically shows about how technicians have been given augmented reality instructions and they are able to use that to perform maintenance on wiring diagrams on an airplane. And the link that I provided also has a short article from Boeing. And so I'm going to quote their article now and say that installing electrical wiring on an aircraft is a complex task that leaves zero room for error. That's why Boeing is testing augmented reality as a possible solution to give technicians real-time, hands-free, interactive 3D wiring diagrams right before their eyes. Traditionally, technicians had to look at and interpret a 2D 20-foot-long drawing and construct that image in their mind and then attempt to wire the aircraft based on their mental model. But by using augmented reality technology, technicians easily see where the electrical wiring goes in the aircraft fuselage, and they can roam around the airplane and see the wiring renderings in full depth within their surroundings, and they can access their instructions hands-free. And end quote. But the article goes on to talk about their theory studies. And according to their article, Boeing's theory study showed that there are performance improvements and a 30% reduction in the time spent doing the job when using augmented reality compared to 2D instructions. And by the way, it's not just Boeing. If you search YouTube with keywords like augmented reality maintenance, you'll see there are many companies who are developing these technologies. So clearly there are some promising benefits of implementing augmented reality instructions on a broad scale in the aviation maintenance environment. But to our knowledge, there have been no FAA studies that have directly examined the feasibility of this approach or validated this type of augmented reality instruction. So what we need to know is it really feasible in the maintenance environment, and does it really improve performance? Next slide, please. Before going any further, it will be helpful to explain the buzzwords. And people often confuse augmented reality with other forms of enhanced technology like virtual reality. And I'm sorry, you can probably hear my cat in the background. But this diagram should help explain the differences. So with augmented reality, the user is augmenting their physical reality with digital overlays like 2D or even 3D objects, and even holographic images. Importantly, the user can still see and interact with their physical environment when they're wearing an augmented reality head-worn device. And this is different from virtual reality, where the user is fully transported to their digital world. And so they're essentially in a completely virtual reality where they can no longer interact with their physical reality. And finally, we have mixed reality, which is where the user augments their physical reality with a digital hologram and 3D models. So they have augmented technology, but they can still interact with their physical world too. And so the red star is where we are sitting on the spectrum. These technologies are often presented using a head-worn display. And what's cool about these devices is that it can present all of the information right inside your small glasses. And it often allows the user to interact with the device using a voice command or hand gestures. So the user can control the information that's being presented either with their voice by talking to the device or by using hand gestures to scroll through the information or even pinch and grab information and drag and drop what they want to see right into their main view. So two of the popular head-worn devices that you may already be aware of are the Microsoft HoloLens and the Google Glass. Next slide, please. So there are many potential benefits of using augmented reality. And remember again, augmented reality is where your reality is augmented by some 3D or holographic images, but you can still interact with your physical environment. And research has shown that augmented reality is a potentially viable technology for improving maintenance performance. It gives the user real-time access to the procedures, 3D visualization of the airframe and its components, and it allows for interconnectivity of maintenance information systems. Augmented reality allows for instant visualization of critical data, and it delivers the key maintenance procedures directly into the view of the technician at each stage of the maintenance, repair, or servicing task. Augmented reality technologies and 3D visualization have the potential to simplify maintenance work instructions by reducing the quantity of text that are in the instructions and instead supplementing it with many more images. It potentially offers the end user more flexibility in where to start and where to pause when strict sequencing of the steps does not matter. And I'll touch more on this a little later on in my presentation. It can track the status of the task, and it can even verify the completion of the task. So this can improve accuracy and reduce the time that technicians have to spend doing sign-offs when they finish their work task. All of these things could increase usability and user satisfaction of instructions when they're displayed using augmented reality compared to when they're displayed using traditional paper-based methods. In a research study last year, displays of maintenance instructions with a head-worn display were shown to improve user satisfaction, but the researchers also documented a decrease in task completion time, mental and temporal workload when the instructions were displayed in augmented reality compared to paper-based instructions. This study used novice participants who were supposed to complete a simple maintenance task on a spacecraft. Other research studies in industrial settings have shown that augmented reality might reduce errors and procedural noncompliance. But importantly, that finding depends on the task complexity and the expertise of the user. So said differently, we don't always see a performance benefit regarding errors and noncompliance, but almost every research study I could find about augmented reality does show improvements, in things like user satisfaction and task time. So again, we almost always see benefit in user satisfaction and task time, and then sometimes we see benefit regarding errors and noncompliances when work instructions are displayed in augmented reality compared to traditional methods. So these research studies have shown some key benefits of using augmented reality, but they also noted that there are some usability and comfortability challenges with the head-worn display. So for example, some common side effects are dizziness or motion sickness, and if the head-worn device is really heavy, then it's not comfortable to wear for long periods of time. Well, maintenance tasks often take many hours to complete. And so if the technology can't be worn for the duration of the task, then it may not actually improve performance. So further research is needed about these usability and comfortability challenges. If the head-worn devices are not comfortable, then they likely are not feasible for broad-scale implementation in the maintenance environment. However, it's important to note that the research studies that I described are mostly laboratory studies. So they were controlled they had very controlled conditions, and they may have used participants who don't really reflect the expertise and needs of real maintenance technicians. Also, these previous studies tested the augmented reality technologies in other industrial settings like spacecraft or construction or welding, but not in aviation maintenance. To our knowledge, there have been no formal field research studies conducted in aviation maintenance environment that have looked at whether augmented reality is really a feasible technology for displaying maintenance instructions. And next slide, please. So the purpose of our study is to examine the feasibility of augmented reality work instructions in the aviation maintenance environment. And we're doing a field study where we actually measure real maintenance technicians in real maintenance environments wearing the augmented reality device and determining whether it improves their user satisfaction and their performance. We are working in partnership with Boeing to design the augmented reality maintenance instructions. And then we're working with a large air carrier, United Airlines, to actually test that technology in the real workplace setting. We are using a phased approach to data collection. So first, we'll begin by asking technicians to simply wear the augmented reality head-worn device and provide feedback on how comfortable, how usable it is, and so on. And this initial feedback from technicians will be used to refine the technology and to gather their feedback on what type of tasks could most benefit from augmented reality instructions. Then in later phases of the research, we will assign technicians to complete a maintenance task using either the augmented reality or traditional procedures. So we will ask technicians to complete a task, and then they will give us feedback via a post-task questionnaire where they can provide their subjective user data about a lot of different things. The things that we care most about are comfort of the device, usability and user satisfaction, subjective workload, and even workplace safety and ergonomic constraints. Then after we collect the data from the maintenance technicians, a second set of eyes will provide a 100% inspection of the task completion and ensure the aircraft are airworthy before being returned to service. This is a precaution being taken by the FAA because this is still an experimental technology and has not yet been validated in terms of safety. But the good news about this is that it will allow us to collect data not only about the subjective user experience, but also more objective data about their performance when using augmented reality compared to traditional instruction types. And in the augmented reality condition, technicians will wear a Microsoft HoloLens 2 device that has verbal control capacity, so they can interact with the instructions using voice commands. And it will essentially display a holographic image of the aircraft overlaid over the physical environment. And we are preventing practice effects by allowing each technician to only complete the task once in each instruction condition. So for our research study, they can only complete the task once in the augmented reality condition and once in the traditional instruction condition. Next slide, please. So now I'll tell you a little bit more about the task that we've chosen for this research study. Now remember, I told you that we were going to get technicians' feedback about the different types of tasks that can most benefit from augmented reality, and we definitely do still intend to do that. But in order to develop the technology with Boeing, we had to choose a task. And the task that we've identified for this research study is the Boeing 777 main landing gear and actuating mechanism lubrication. We chose this task because it is routine maintenance, so it occurs pretty frequently for the aircraft. And it's pretty tedious. It takes a long time, and it has a fairly high error rate. During accomplishment of this task, the technicians will work in pairs to work their way across the landing gear and systematically lubricate each fitting one by one. They do this by using the graphics in the instructions to locate those fittings, and then they lubricate them. Finally, they check off each fitting as being completed. And one technician is the primary person who actually lubricates each fitting, and then there's a support person who handles the paperwork and the necessary equipment like ladders, forklifts, etc. There are roughly 200 fittings per side of the aircraft, and some locations can be ambiguous or visually obscured. So certain locations are frequently missed when performing this task. It is especially important to note that not all fittings can be displayed on their traditional instruction type. Rather, they're depicted using flag notes. And another complication is that not all of the fittings receive the same type of grease. There are actually 3 different types. So not only do the technicians have to find each one of the 200 fittings and lubricate them, but they have to use the right type of grease for each one. So the difficulty in finding some of the lubrication fittings, as well as making sure you use the right type of grease, makes this a particularly error-prone task type. The task takes roughly 4 hours depending on the technician's experience with performing it. And given the sheer number of locations and the tediousness of the task, complacency and fatigue errors are common. It is pretty common to miss 1 or 2 fittings. And the reason that we know this is because after task completion, a second set of eyes will do a random check to ensure that the fittings are properly lubricated. So during inspection, quite often the inspector will find that there are some locations the mechanic missed, or in some cases, the inspector may miss that same location as the mechanic because, again, the location is ambiguous or visually obscured. So what's nice about the augmented reality is that, again, it's not just flag notes. It's an actual 3D holographic image of the entire aircraft space. And so technicians can wear the HoloLens device and they can actually walk around the aircraft and find all of the 200 fittings very easily compared to just looking at the 2D traditional instruction type. Next slide, please. So again, we are asking technicians to perform the landing gear lubrication task with either using the traditional instruction or augmented reality instructions. And here's what it looks like when you perform the task while wearing augmented reality head-worn device. You can see that I've circled in red, the technician is wearing the head-worn device and he is also operating the lubrication gun. With the augmented reality capability, the landing gear is holographically imaged so that it reflects all of the 200 fitting locations with fly around or fly through technology, which is hypothesized to be an improvement over the traditional 2D graphics where the hidden locations are just shown via flag notes. And also with the augmented reality, fittings can be graphically depicted in different colors to display their status. So for example, an unlubricated fitting could be shown in red, while a completed one could be shown in green. So this allows the technicians to have easy visualization of what fittings are left to complete, and is again hypothesized to be an improvement over the traditional 2D instruction type. I really wish that I could show you a video or something of what this technology actually looks like from the user perspective, but it's Boeing proprietary information right now, so I can't show you a video or anything. But I hope you can imagine that inside, wearing the head-worn device, it looks like a hologram that is exactly the same as the real life landing gear, and it's holographically displayed over the real landing gear. But again, with augmented reality, the user can see the hologram and the 3D information, but they can also still interact with their physical environment. So this is why the technician is able to wear this device and see the instructions with augmented reality, but he can still use the lubrication gun at the same time. And for this lubrication task, it's usually a two-person job, but you can imagine this technology could be used for single-person tasks as well. And clearly, it's hands-free, so he can do it by himself in a single-person type of task without needing anybody else to operate the lubrication gun or flip through the procedures for him. It's all there, right there where he needs it. Next slide, please. So, to determine the feasibility of this augmented reality technology in the aviation maintenance environment, we are measuring many different variables of interest. We are measuring things like user experience, usability, workload, user satisfaction, and their comfortability of wearing the head-worn device. We are also measuring workplace safety and ergonomic constraints. So for example, did they trip, slip, or fall while wearing the device, particularly when they use equipment like ladders or forklifts? We will control for basic demographic information like experience with the task and technology enthusiasm and familiarity, because we know these things may shape user perceptions of the technology. If you're more experienced with the task, you may not need the augmented reality because you know where the lubrication points are. And if you're more enthusiastic or familiar with the technology, then you may be more accepting of it in the work environment. So these are important covariates for us to consider when we do our data analyses. As I mentioned before, we're doing this research study in a phased approach. First, we're only measuring the variables at the top of my slide, subjective user experience, things like usability, satisfaction, comfort, safety. But in later phases of the research, we intend to have the technicians actually complete the full lubrication task using either augmented reality or traditional instruction. And then we will have, again, that 100% post-task inspection where a second set of eyes will verify the task completion. We are intending to measure the number of errors and non-compliances, as well as efficiency measured by time on task. And it's really important for me to stress here that we are not interested in individual technicians' performance, but rather we aggregate the data across all participants. So it can't be used to harm technicians or the air carrier united, and it's not a compliance or like oversight issue. It's just for us to collect data about whether augmented reality really does improve performance compared to traditional instructions. We are hoping to see that augmented reality will be a feasible approach to conducting aviation maintenance operations, as well as improving their performance, efficiency, usability, and user satisfaction. And the information collected during this study will be used for many things. For example, to help us further develop augmented reality applications, flesh out realistic use cases, identify what task types it can best support or where it's really needed, and just to inform the overall feasibility and human factor considerations for the use of augmented reality applications.
Sorry about that, Kylie.
That's okay.
Please continue.
Next slide, please. So last year we visited a maintenance facility. It was United Airlines San Francisco. Remember that they are collaborating with us to test the technology. So we tested it out by...
Hopefully that was it. Sorry, Kylie.
That's okay. So last year we visited the United Airlines facility to test the augmented reality out. And so here's the full research team and some of the technicians who gave us feedback. And we were ramped up to begin data collection in April of this year, but unfortunately data collection has been put on hold indefinitely due to the COVID-19 pandemic. The pandemic has brought some pretty significant challenges for us as researchers, like shortages in both the aircraft and the personnel that would be needed to collect data on, right? And this is due to the dramatic drop in air travel. There simply aren't enough people or aircraft for us to collect data with right now. And even if there were, there are other perhaps more practical constraints, like the need for social distancing between the researcher and the technician, increased sanitation protocols for the augmented reality devices, especially because they're on your face, and the need to wear a face covering fogs up the HoloLens, the augmented reality device. And so when you're wearing a mask, you can't really see the hologram also. But we hope to be able to continue the research and report the findings later on when things do return to normal. But for now, we're just in a holding pattern waiting for the COVID-19 pandemic to resolve somewhat. Next slide, please.
Hey, Kylie, sorry to interrupt. The record, unrecord, just want to remind everybody, you may have had a pop-up saying continue. Just hit continue to remove the pop-up. Everybody has to do that individually. Not sure why the record button went off, but we killed it. Undid. So just a little reminder out there. Sorry.
No, that's okay. I'm almost finished anyway. So just want to quickly acknowledge that the support and funding for this research. The research is being prioritized under the CAMI Flight Deck Human Factors Program Directive with FAA Human Factors Research Division. And we're also actively collaborating with Boeing and United Airlines in order to develop the technology and to test it in a real maintenance environment. So thank you very much for the funding sources as well as the collaborators for participating in making this study happen. And next slide, please. That concludes my formal presentation, but thank you again so much for the opportunity to present to you and for just hearing me out. I think we probably should have plenty of time for questions. And if you're interested to contact me or the other researchers who are involved, then all of our contact information is displayed here. So even if you don't want to ask me a question during this Q&A portion, then you can feel free to contact me anytime and I'd be happy to discuss this research study. I think it's really cool, so hoping to be able to report some good findings later on.
Well, thanks, Kylie. As some of the things you're covering there, it made me feel like just a couple years ago we're calling them science fiction, and now it's like reality. You see where we're going toward, it's like, ooh, this is exciting. So just so you know, we do have a number of questions that have come in throughout your presentation, and I'll present them to you and for discussions, and as long as we can before we run out of time. It's okay?
Sure, sounds great, yes.
The first question, this is good technology, but what is available now rather than a head-worn display? Also, how much testing has this AR been used in the real world, in the real environment? There are a lot of places where external aids may not be practicable.
Yes, thank you for acknowledging that. So, okay, first part of the question was what again? I only remember the second half. Can we maybe do that one at a time?
No, good technology. What's available now rather than the head-worn display?
What's available now? Well, I'm pretty much only aware of augmented reality being displayed in some kind of head-worn device. I'm not familiar, and we're not researching anything other than augmented reality head-worn devices, but there are already some head-worn devices that are available, like Microsoft HoloLens. They had a first generation and now they're into their second generation of it already. And regarding Google Glass or other things like that, I'm much less familiar, but so I'm sorry I can't answer that a little bit more specifically. If you meant what products are available that aren't still subject to a research study, I encourage you to Google it, basically. There are many different companies out there who are already developing the technology and selling it for commercial use. The reason that we're looking into it is for research purposes. So, of course, my findings of this research study can only generalize to the exact technology, the exact task, and everything that we're using. But if you're interested to learn more, then I think you have to Google it. I'm sorry again for not being able to provide a more specific answer. And then the second half of the question was limitations of the technology?
Yeah, like real world limitations, where it can be used, where it might not be used.
Sure. So we're still in the very, very early stages of actual research conducted by the FAA on this technology for aviation maintenance. And I can't really speak beyond that, but I know that most of the research that has been done has been conducted for other industrial settings outside of aviation, so like welding, construction, spacecraft, and it seems to work pretty well there. But again, I'm unaware of any studies specifically for aviation maintenance. I will say that for those other research studies, the augmented reality technology seems like it improves user satisfaction, but not necessarily performance. And also that there are some pretty significant comfort or ergonomic constraints with using it. So as I mentioned earlier, the device can get heavy. If you wear it for long periods, it can cause like strain or just discomfort right here on the bridge of your nose or all around your head. Some users experience motion sickness and dizziness, or eye strain is another big one. So also, when wearing the device, it's really important to like flip up the visor or take the device off anytime you're walking around or when you're using a ladder or other necessary equipment. And so that's certainly one limitation, is that if the technicians have to take the device on and off a lot of times, anytime they're trying to move around the aircraft, it could actually take them longer to perform the task compared to with traditional procedures. I don't know, it's an empirical question. We have to investigate that. So those are some limitations of just the augmented reality head-worn devices in general. And then limitations of specifically the way that we're doing it are that, for example, we've programmed the devices to display red and green, but color blindness or color deficiency is certainly a consideration, and those might not have been the best color choices for us to make. Also, we've considered that we should use different colors to display the different types of grease that are needed, because remember, there are 3 different kinds that are needed for this one task. And so unless the augmented reality can display all of the information that the traditional paper procedures currently display, then it won't be effective. So we need to find a way to display the different grease types and cautions and safety warnings and all of the other beneficial information that maintenance technicians receive currently needs to be put into the augmented reality device before it can actually be effective and implemented wide scale, in my opinion. I hope that answered the question, but whoever asked it, please feel free to ping the chat box again, I guess, if you want to know more.
Okay, thanks, Kelly. So I'll go on to the next question we have. We are seeing LiDAR sensors being incorporated into mobile devices. Can we envision scanning surfaces and image processing software that will help assess possible damage? Anything on that aspect?
I'm not super familiar with it, but I love the creativity and the big thinking that was put into that question. I mean, welcome to the future. We're here. We're starting to do it. So I think it's definitely worth exploring. And I will say just briefly, I know that visual inspection of aircraft used to be the norm, but there are more advanced technologies for it now. I'm unaware of those being investigated by FAA researchers, though.
Okay. Let's see. Next question. How much does AR and VR impact training of mechanics? And how can older aircraft take the benefit of this kind of training and technology?
Sure. Thank you for asking that. So training is actually one of the biggest applications I'm aware of for augmented reality technology. There are many applications. So similar to how we're instructing maintenance technicians to do their job, the medical industry has instructed healthcare workers using AR. It can support surgery by providing virtual overlays to guide medical practitioners, and it also has other applications like astronomy, welding, etc. But research shows that not only can it be beneficial for real-time work instruction, but it's very beneficial for training. So said differently, even if you don't provide real-time work instructions using the augmented reality, if you train employees using it and let them meaningfully engage with the equipment using these 3D images and holograms, then it does seem to improve training outcomes. And I forgot if there was a second part to that question. Sorry, my short-term memory is not good today, y'all. I'm sorry.
Not a problem. No, it was about using it for older aircraft.
Oh, older aircraft.
Aircraft too.
That's a good question, but one thing that I'll say is that every task has to be programmed into the augmented reality. It's not like boom and it's here, right? An engineering team had to take the CAD diagrams from Boeing's maintenance manuals and integrate those into the augmented reality. I suspect that this certainly could be done for older aircraft, but I think that because it's so experimental now and we need to investigate the just feasibility of using this technology, we need to start with a few tasks we think it will work on, and then if we find that it's feasible, then expand it to different kinds of aircraft and things like that, or different task types.
Interesting. Another question, you mentioned about the color coding for grease. That still apply to similar question, and maybe the same thing, but color coding in accordance with the fitting for the different types of grease. Is that something that could be done?
I'm not sure I understand the question. So could you say it a little differently? I'm sorry.
Is it possible to color code the fitting for the type of grease needed?
Yes, I understand now. So I think that that is really similar to what I was trying to say earlier, but I will say it again. So right now we have only depicted the fittings according to their status. Has it been lubed, yes or no? If yes, it's green. If no, it's red. But I can easily imagine an improvement to this technology where we display the unlubricated fittings with the type of grease that they need to be lubed with. So, and then after they're lubricated, they could still change to green to display that they've been completed. I think that answers the question.
Sound like it did to me.
Okay.
Yeah, it's a bigger topic. Had a lot of conversations, still have a lot of questions coming in.
Okay, great.
About 9-10 minutes left. So
Okay, great.
next one is, although there may be clear benefits, it requires development, conversion of existing manuals. What's the process and cost of converting or the new manuals? So something
Sure.
I'm sure a lot of our audience would like to know.
Absolutely. So, I will say I can only speak from watching the one research team and collaboration. I don't know how much it costs or how much time is involved in adapting this for broad scale use. But I will say that for every single task on any aircraft type you want to use augmented reality for, you have to develop the specific application. So it means that an engineering and research team had to get together and collaborate closely to convert the CAD diagrams and other information from the maintenance manual into the augmented reality application. And then you can imagine if it's feasible and if companies start to use the technology, then they have to buy enough devices for every technician who will use them as well. So there's a cost of developing the instructions in the first place, and then there's the cost of the devices themselves. And of course, as researchers and as Boeing engineers, we have many projects going at one time, but I will say that we have been working on this one for about a year, and it's in a good place after 1 year. I don't know how much exact time has gone into it, but it's been significant. And that time has to be spent for every task type that you want to use augmented reality for. So I think it can add up.
Okay. And almost on the lines of that, the next question came in, asking about the ultimate goal of augmented reality systems, of them being either created by the operator, or is it something really just the manufacturer will create in service centers, that side versus an operator?
Well, I think that that's really up to industry. As just an FAA researcher, I can't advise one way or the other about whether you should choose to develop your own. But I think there may be some information that the manufacturers have that they use when they're developing the manuals that it might be more difficult for independent operators to get access to. But I also know that there are different companies who are already developing these applications. So I don't think that it's a manufacturing only endeavor.
Okay.
Sorry, I want to say one more thing. Our goal as FAA researchers is not to specifically only support manufacturers in developing this technology. We are interested in whether the technology is feasible as a way to improve performance in the workplace. And so from our perspective, it really doesn't matter who develops the technology, manufacturers versus operators. We just want to know if it's a realistic, feasible human performance solution.
Okay. Yep. Sounds like if someone has to dedicate to creating their own augmented reality for maintenance tasks as an operator, they could do it.
Yeah, I think that that's right. I think that's right.
Here's one, I believe, from our international community. Can the use of augmented reality in maintenance tasks minimize possible errors that result from interpreting the procedures by non-native speakers of the English language?
Okay, one more time. Can the augmented reality
Can AR help reduce possible errors that come from misinterpreting procedures by non-native English speakers?
Yeah, okay. I thought I heard you the first time, but I wanted to get it right. So I know that a common error type is misunderstanding instructions that are not written in the user's native language. And one easy way to improve performance for any maintenance technician without the technology is just to put it in their language. This can certainly help. But in lieu of that, I can see how the augmented reality can support reduction in error because it uses pictures and in our case, it highlights every single one of the lubrication fittings that need to be lubed. But the safety warnings, cautions, and other information like what type of grease to use are still displayed in text format, not picture format, if that makes sense. So any text that is inside the augmented reality could be mistakenly read by a non-native English speaker. So then I would still encourage that that text be translated to their native language so that they can better understand it.
Okay. So it seems like the pictorial and diagrams do help out a lot together. There has to be words going in there to say what the pictures mean. So it was a question from our audience. I believe we have time for one more question. So in the course of your research, did you consider the potential side effects of overconfidence in AR, VR during maintenance activities?
Overconfidence of
Yes.
AR and VR. You mean like trust in automation type of things?
I'd say really trusting the AR and VR. I guess overconfidence in those systems in which if something doesn't seem right, it may not be right.
Right.
It's, what you've seen is what's real, which may not be true.
Sure. That is a great question. Thank you so much to whoever asked me that. I am going to go back to my lab and ponder that, actually. But my short answer for now, without having given it much thought, is that the closest approximation we have currently in our research plans are to measure users' experience and familiarity with AR technology. So, for example, it was part of video games before it was part of work life, right? And so if they are very familiar with the technology, they may have differences in how they perceive it and how confident they are in it and things like that. And so we currently plan to ask users some very basic questions like that. But this question about overconfidence and trust in automation or trust that the information is correct is a really, really good consideration. So I'm going to think about it, but I might add some questions to the set that we give participants basically and try to measure that a little bit more fully, because I think you're right that it certainly does matter. Thank you.
That brings us to the end of your session. You take a breather now.
Great, thank you.
We do appreciate it. Interesting too, and still think about being science fiction at times, but no, that's where we are now.
Yeah, absolutely. Thank you again for the opportunity to present. I really appreciate it.
Thank you. And right now we'll go ahead and take a 10-minute break before our next presentation. We'll see everybody back at the top of the hour. Thank you. Hey, welcome back, everybody. Now I'd like to welcome Mark Colburn, recently retired officer and 34-year veteran of the Dallas Police Department, with 30 of those years as a pilot for the helicopter unit. Mark, I'll hand it over to you. Thank you for joining us.
Thank you, Steve. Appreciate it. Can you all hear me okay? I'll bring this up.
I can hear you. It sounds good.
Okay. Here we go. Are you able to see my screen? Oh, there it is.
Yeah, share it.
Okay, I got it. All right, sorry.
No problem. Yep, it's up.
Okay, very good. Thank you. What I'd like to share with all of you today are some of the challenges still facing the continued safe integration of unmanned aerial systems into the national airspace system. But before I get into that, I'd like to relate a safety. This is a Rotorcraft safety seminar, so I wanted to relate a safety story, something that's kind of kept me, I guess you could say, alive for the last 40 years of my flying career. I started taking flight lessons back when I was at Mesa College in Grand Junction, Colorado, 41 years ago. And I got up to about 26 hours of flight time, and I ran out of money. And so I was working for a gentleman at the time. He was part-time. He was a former Army Green Beret. And he said, "Hey, Mark, why don't you go in the Army and fly helicopters?" And I thought, wow, that sounds pretty neat. But I asked him, I said, "Don't you have to have a degree for that?" And he basically said, "No, you don't." So I went down to a recruiter, and sure enough, my friend was right. And the following summer, I found out I find myself going off to Fort Dix, New Jersey first for basic training, and then I went down to Fort Rucker, Alabama for the Warrant Officer Candidate Rotary Wing Development course. And when I graduated a year later, they sent me over to South Korea. And my first unit was at Camp Humphreys, and I was assigned to a general support Huey unit. And we flew missions all over the country. And we supported like Armed Forces Korea Network, the radar sites. We did flights up into the buffer zone, which were just south of the DMZ. And it was fantastic flying and a great place to learn coming right out of flight school. But our main mission while we were there was if Kim Jong-il decided to send his communist forces across the DMZ, our job was to haul troops into battle. And we practiced that an awful lot. And there was occasion when we'd have a mission that would pop up that we just didn't quite feel comfortable with, but we didn't know how to articulate that. And we had a hard time, deciphering, okay, we know that there's something not quite right here, but we can't put our finger on it. So we go to the commander, we say, "Sir, we can't take that mission because it's unsafe." And he would say, "Well, how is it unsafe?" And we would just say, "Well, it's just unsafe." And he said, "Well, that's not good enough. That's our job. Got to go do it. Go out and do it, and just be careful. Be safe." Well, as we all know, be careful and be safe is kind of a term that is really kind of nebulous and ambiguous. And everybody has a different interpretation of that. I mean, you tell your family when they leave the house, "Hey, be careful," when you're leaving the house. And we also, while I was there during Team Spirit of '82, it's 7 days into a 10-day field exercise, our unit was out doing a air assault, and I was on another mission that day, so I didn't get to see this, but they were flying a 10-ship mission, and the lead aircraft hit a wire, a high-tension power line. And just by the grace of God, everybody survived that accident. But it was a very, very trying time. Well, it wasn't until about 10 years or a decade later, I'd already joined the Dallas Police Department, and I'd also joined the Texas Army National Guard, finished up my tour in the Army and joined up the Texas Army National Guard. And some brilliant individual, I still don't know who it was, came up with this idea of assessing risks and hazards before you go fly. And I was thinking, God, this is perfect. This is exactly what we needed when I was over in Korea. And so you identify the hazards and the risk, and you put those down on paper, and then you go out and fly the mission. You know where all your problems are. And gosh, I really wish that we had this when I was out there. But the point I want to make about this is, over the years that I've been flying, this thing of doing a risk assessment has become a natural part of my flying career, and even part of my everyday daily life. You don't have to do a risk assessment on a piece of paper. You can do it in your head. You do it before you go fly. You do it while you're flying. You do it after you fly. And you take that with you to everything else that you do. I'll guarantee you that just about anything that you do during the day, the most dangerous thing you do every day is get in your car and drive to and from work. And this would be a great place to take that risk analysis type mentality, that safety mentality, and put it into your daily life. 38,000 people are killed every year in automobile accidents in this country. And you can also carry it, when you go through an intersection, you look right, you look left, you look right. Otherwise, if you don't do that every time, just like you do when you go flying, there's probably a good chance you're going to get T-boned. Now, I've survived a 40-year flying career with this type of mentality, and like I say, I'm an old man, so you can trust me on this. Okay. Now, in 2012, I started flying drones, and I was attending an Airborne Law Enforcement Association convention in Reno, Nevada, and there was a father and son there that were selling these small, upper left-hand corner there in your screen, these small electric-powered quadcopter distributed power, drone. And I went nuts over this thing, and I bought it on the spot, and I brought it home. And the thing about this thing was it had a very simple Arduino board controller, just a basic controller that was developed by Georgia Tech University, the people there years ago. It had no GPS, it had very little stabilization. It was difficult to fly. As a matter of fact, I attached dowels and ping pong balls to the skid so I wouldn't roll it over. And it didn't have very much power, as I found out one day when I tried to fly it up on Grand Mesa in Colorado at 9,500 feet. It made it about 2 or 3 feet off the ground and promptly plopped back down to the ground. And then it finally dawned on me, hey, performance management. It's high altitude. It's not going to fly the same way as it did on the ground. Now, the following year on Black Friday, I bought this one that's in the lower left-hand corner. It's called a DJI F450, and you had to assemble it yourself. And it had a very basic, what they call a nozzle light controller, and I used the Devo 7 hand controller that I gotten with my Rotor Concepts drone. And at one time, and I've owned all of these drones over the years, and one of the things I wanted, oops, wait a minute, I went too far. Let me go back. There we go. One of the things at one point, I thought I wanted to fly drones commercially. And so I applied in August 2015 for I started an LLC, a limited liability corporation, and I applied with the FAA for a Section 333 exemption. And about 8 months later, it was granted. And then in August of the next year, almost a year later, I was in one of the first batches of people to get a night waiver or a daylight waiver or permission to fly commercially at night. And I felt pretty proud about that because I had originally included wanting to fly at night in my original 333 application. Unfortunately, I never really did do a whole lot with the business because when the FAA came out with Part 107, they really made it easy, kind of easy. I thought they made it too easy to get a Part 107 license, remote pilot certificate with, and they didn't include a flight test. So I was really hoping that they would have done that, but unfortunately, like I say, they did not do that. Now, last year, in March of 2019, I was appointed to the FAA's Drone Advisory Committee. And I just want to say that was quite an honor to be appointed to this group. And I think a lot of it had to do with all the work that I've done over the years with the Airborne Law Enforcement Association, another organization called the Law Enforcement Thermographers Association, and also with the IHST, the International Helicopter Safety Team, and the United States Helicopter Safety Team. And I've been involved with the IHST since the year after it was formed in 2006. And one of the projects, the recent projects that we worked on was trying to reduce fatal accidents in the helicopter community. And I'm sure you'll hear a lot more about that over the next couple of days. But I chose to take on this particular safety enhancement, which was try to identify how UAS and optionally piloted aircraft can reduce fatal accidents in high-risk manned helicopter operations. Now, my dream has always been, wouldn't it be great if we could install this automatic technology, this stabilization technology that's in these small drones into the helicopter fleet? And that was one of the things behind this, not to replace the pilot, but to make the pilot's job easier and provide a safety net for those situations where a pilot might find they are in over their capabilities, such as deteriorating weather conditions. So if y'all haven't looked at this report, I recommend definitely taking a look at it. Now, in December of 2013, Charlie Rose interviewed Jeff Bezos, the CEO of Amazon Corporation. And well, you know, he's probably the richest guy in the world right now. I'm not sure exactly, but I'm sure since February he certainly is, because Amazon stock went from 1,700 to 3,400 a share by August. And it's one of those I kind of kick myself for missing. But at any rate, he pretty much told Charlie Rose that within 5 years, he would be delivering packages with his drones. Well, Jeff, like other companies like Walmart, Google Wing, FedEx, and others, they hoped they could bend the FAA to accommodate their drones. In other words, maybe perhaps like segment the airspace, like they're proposing in Europe with their U-space and what they call their danger zones. I don't know why they call them danger zones. I don't like the word danger anywhere near aviation. That's just not a very good term to use. But at any rate, they finally realized that they would have to work within the existing system. And that's a system that's been in place since the 1950s after two passenger airlines collided over the Grand Canyon. And that system's called the air traffic control system. And by golly, you know, it works pretty well. And like my father used to tell me, hey, if it's not broke, don't fix it. Well, as I say, 7 years later, we're still no closer. Well, we're a little closer. We're closer to widespread drone package delivery. In other words, drones are not blotting out the sun in the sky yet. And you might ask, well, why? Why is that? Well, there's some remaining hurdles because of current regulations. And the first one is, of course, you can't fly over people without a waiver. You can't fly at night, and you can't fly beyond visual line of sight. You got to have a waiver for all these things. And you can't control a UAS from a moving vehicle. So that means that if you send out delivery drones, delivery trucks with drones that pop out of the roof or whatever, they're going to have to remain stationary. And another thing is you're not really supposed to drop anything from aircraft. So that's why a lot of these drone delivery companies have been experimenting with tether systems where they really don't want to have to land the aircraft and drop off the box. They would rather lower it to the ground. And that having to land creates all kinds of problems, you know, dogs in backyards or front yards or whatever, pets and just people and obstructions and that sort of thing. And another thing is you need exemptions from all FAA regulations that you can't comply with. And because all of these regulations were originally formulated for manned aircraft. And here's something else too. You can't do package delivery under Part 107. So the solution that a lot of these companies have found is you apply for a Part 135 air taxi or carrier certificate. And you need three things for a Part 135. And like I say, you need an exemption from every individual regulation that you can't comply with because there's not a pilot on board. You need DOT economic authority, and you must get that prior to receiving your 135. And then you have to go through the 5 stages of obtaining a Part 135 certificate. The third stage of that process is pretty time consuming. That's where you submit your application. After you've submitted your application to the FAA and all your manuals, flight manuals that are required for Part 135, that's the part where the FAA reviews everything and makes sure that you've got everything in order. And then there's 4 types of Part 135. And really the one that you want is the standard 135. And that allows you to have multiple PICs and pretty much as big of an operation as you want, except that you have to get approval for each individual type of operation, which for package delivery companies, that shouldn't be a problem. And this is the one that, this is the exemption that Amazon Prime Air got back on August 27, 2020. And as you see on the upper left-hand corner, we're talking about a large number of exemptions that they had to apply for before they could get this. And this is in addition to their Part 135 certificate. Now, currently, most drone deliveries are being done outside the United States in sparsely populated areas or over water or to and from islands. And really currently right now, they're only being flown in the US for proof of concept and in testing in integrated pilot program UAS test ranges. And but outside of these IPPs, that when they have to move outside of that, there's going to be quite a few things that they're going to have to do. Operators of UAS over 55 pounds or operating under Part 91 or 35 are probably going to need to get either a type certificate, a waiver, or an exemption, or as what the FAA just released here recently, apply for a Part 21.17B special class category airworthiness certificate. And this was a policy released by the FAA on September 18th, 2020. The docket number is down there at the bottom. And what they've done is they're pretty much modeled this towards the package delivery folks. And here's another issue that why they want to get Part 135. There's going to be a lot of state and local government bodies that might want to seek to restrict and limit or drone deliveries over certain population centers. And by getting the 135, the Airline Deregulation Act of 1978, it gives them a little bit of favorable protection to U.S. drone delivery companies because it prevents those bodies from interfering in air commerce. Now, though, when they do move out of the IPPs, they're still going to have airspace authorizations to fly in controlled airspace, and eventually, once unmanned traffic management system is up and running, they'll have to get approval through that also. Now, there's currently 2 methods available to fly drones commercially or even recreationally, and that's through the low altitude authorization and notification capability, are called LANCE, and the FAA's drone zone web portal for everything else. In other words, that covers let's say you want to fly in an airfield with a zero, and I'll describe this a little bit more, a zero altitude block, you would have to go through the drone zone to get that. Now, the LANCE is going to be a UAS service supplier, a USS, and we'll talk a little bit more about that. But here's an example of I use a company called AirMap to get my Lance approvals when I go fly. And you can see the screen here on the left. When you bring it up on your phone knows where it is. So it shows the location, and it draws at least on mine, it draws a 2,500 foot circle around the area where you're located. You can also do a route, or you can put in your own area that you want to define. And then as you click through the screens, it goes through these checklists. And one of the things that we recommended recently on the Drone Advisory Committee was for the FAA to actually encourage USS providers to add a simple non-punitive risk assessment into this process. Now, over to the right is the authorization. Once you apply for the authorization, this is what you get back via text message from the automated system. And it usually comes back within maybe a minute or two, and then you're off and flying. Now, when we talk about profitable package drone delivery, I believe the only way it's really going to be profitable is if it's entirely automated, and they'll have to be able to do it beyond visual line of sight without a waiver. And of course, that's probably eventually going to require new regulations, but we'll see. And the problem is, it's the drone operator's sole responsibility to maintain separation and avoid a collision in controlled or uncontrolled airspace with manned aircraft and other drones. And that's pretty much been the mantra of the FAA since this thing started. And the solution is that since there is no pilot on board, the UAS for see and avoid and other air traffic, adequate replacements are needed. And that's where remote ID comes in, the unmanned traffic management system, the urban air management system, redundant command and control for controlling the drones, and detect and avoid is going to be a huge problem in this whole thing. Now, here's an example of the unmanned aircraft systems traffic management. And it's going to include everything in the low altitude airspace below 400 feet. And eventually, what the FAA is planning on doing is tying the system together with the air traffic management system with what they call a flight information management system, or FIMS. And that'll be developed by the FAA to pass information back and forth. And let me just mention real quick, you see the FL 600 there at the top of the screen? Well, while I was researching everything for this presentation, I found out that what the FAA calls everything above 60,000 feet, and NASA too, they call that upper class E airspace, and that's for everything above 60,000 feet. And there are going to be electric powered unmanned aerial systems operating in that airspace up there. And it's if you've never looked at any of that information, it's quite fascinating. Most of the plan is how to get stuff up and how to get stuff back down. But I just wanted to mention that real quick. The FAA just came out with these two documents back in June. The Next Gen Concept of Operations version 2 for UTM, and they also came out with Concept of Operations version 1 for urban air mobility. So, the FAA is working really hard to get to a place where we get these machines integrated into the airspace system. And the first step, of course, to unmanned traffic management is the remote ID. And the remote ID rules, I've been assured that they will be out by the end of the year. As a matter of fact, those rules have already been sent to, I think it's the Office of Budget and Management for their approval. The FAA sent that over about 2 or 3 weeks ago, and they're still on track to get remote ID out before the end of the year. And The FAA said many years ago, basically, that UAS operating in low altitude airspace can't use ADS-B, mainly because there's just not enough codes. So that's why they came up with remote ID. And there's two different types. There's network and broadcast remote ID. And the network RID is what I just showed you with the Lance. When it gets integrated into the UTM system, it's going to be kind of a Lance on steroids, as I envision it. Okay. The other form is broadcast, and each drone is going to have to broadcast a signal that anybody can pick up, and that's going to be in the unlicensed Wi-Fi and Bluetooth ranges. And the whole idea behind remote ID is for identifying UAS flying in the national airspace system. It's not in itself a collision avoidance solution. Okay, the way it was described last week during a conference that I sat in on. The whole idea is a law enforcement officer should be able to look at his cell phone and identify all the drones that are out there flying around with an application. And that's what they envision. That's one of the things they envision. Now, all UAS, except for hobbyists flying small unmanned aerial systems or remote control aircraft in federal recognized identification areas, in other words, flight clubs, RC clubs, will be required to participate in UTM. But the problem is not all manned aircraft are going to be required. It's going to be voluntary. And all UAS must remote ID, but not all manned aircraft will be required to remote ID. Either have a transponder ADS-B out. Now, manned aircraft equipped with ADS-B out or radar transponders are considered cooperative. And uncooperative manned aircraft have neither. And that's a pretty large percentage of the US aircraft fleet. Ultralights, paragliders, light sport aircraft, ag spray planes, and helicopters, balloons, home-built helicopters, jetpacks, all those things. And that's where I think we're running into a lot of problems with this. And hopefully, there are some technology solutions out there. And as a matter of fact, I talked to a gentleman yesterday who's working on a X-band radar system that he's proposing to incorporate in this UTM system. It's some fascinating stuff. Just one quick note here at the bottom: all the detect and avoid documents that I've read. They describe uncooperative manned aircraft as intruders. Uncooperative aircraft as intruders. I thought that was kind of interesting. All right, in ConOps version 2, in this particular section, it states that beyond visual line of sight operators must utilize UTM services in their operation. So that's going to be a must for everything across the line. And those services include, but are not limited to, that long laundry list there. And also mentioned is the strategic deconfliction through the sharing of flight intent and negotiation. In other words, a network connection to the internet and to a USS provider. That's what I'm saying, going back to that Lance on steroids. Now, the FAA in Next Gen ConOps 2 is asking manned aircraft pods to voluntarily share their flight intent to operate in a low altitude airspace via network connection to a USS provider. Now, I'm just going to throw this question out there. Is the FAA asking too much from manned aircraft pilots? Well, there's one particular paragraph in Next Gen ConOps 2, which really got my attention. And it starts out, UAS operators share separation responsibility from other airborne traffic. Okay, that's reasonable. That's simple see and avoid. I'm all on board with that. UAS operators desiring to operate in areas with high density or heterogeneous traffic may be required to equip with detect and avoid technologies to meet their responsibilities. I can guarantee you that's definitely going to be that is definitely going to be a requirement. And those might include ground-based systems, like I say, a ground-based radar to, like, say, for instance, if you've got a railway and you want to inspect that railway for like 5 miles, they'll set up radar sites to detect uncooperative unmanned aircraft that are coming through there, or other drones that aren't equipped with RID, and there's probably going to be some of those out there. And there's also companies who are experimenting with acoustic systems as well. Now, this is where I think the FAA is, we're kind of straying a little bit, but it said low altitude manned aircraft operating in both uncontrolled and controlled airspace have access to and are encouraged to utilize UTM operations planning services to deconflict their aerial work. Now, I can fully see helicopter EMS operators probably doing this and getting involved in this, because they have a vested interest in preventing drones from flying into their scene responses. I'm thinking it's going to take a lot of work to get, like, say, low altitude, power line patrols or pipeline patrols, helicopters, and especially ag spray planes to participate in this thing. But we'll see. Now, in ConOps version 2, and later on in section 3.4, the FAA outlines various scenarios that can take place between a UAS and a manned aircraft at low altitudes. And in one of the scenarios, they suggest that UAS have the capability to at least receive cooperative manned aircraft beacons, in other words, ADS-B. Well, DJI Corporation is already doing this with some of their newer drones. And that was one of the things that we also, in the Drone Advisory Committee, encouraged the FAA to try to encourage manufacturers to include that in there. In another scenario, the FAA envisions manned aircraft can likewise have equipment installed that can detect information transmitted by UAS. In other words, they're RID beacons. I say, yesterday I talked to a gentleman that's in Florida that his company is developing a system that will take that information and feed it into, like, say, if you've got ForeFlight or your Garmin machine, would take that RID information, and he's got patented technology. And I'm telling you, it's very encouraging. Some of the technologies that are coming down the pike on this, and what I heard yesterday gives me a lot of hope that this it's still going to be an issue, but maybe it won't be as big of an issue. Now, as a 40-year helicopter pilot that's operated in a low altitude environment, I think this second part of this sentence is very troubling. And it reads, low altitude manned aircraft pilots share some responsibility with beyond visual line of sight US operators for maintaining separation from each other. Now, apparently, the Embry-Riddle University did a study on this last year, and they discovered that skilled pilots approaching a runway usually cannot see encroaching small unmanned aerial systems and virtually never detect motionless unmanned aerial systems. And in only 12 of 40 approaches where they were approaching a runway, that's only 30% of the pilots actually spotted the drone that was out there moving around. And in only 3 of the 22 approaches did the pilots spot a stationary small unmanned aerial system. And this was a study where the pilots knew they were out there and they were actually looking for them. Well, the problem is drones get lost just like birds and everything else out there, and other aircraft as well. If it's below the horizon, it gets lost in that horizon. And most drones, unfortunately, have all their lights under the arms because that's, it's easier for the operator to see. And unless you're flying at night, your drone is not required to have a beacon. So there's nothing on top. And I'm telling you from personal experience, it's very, very difficult to spot a drone in the air especially even if you know it's out there and you're looking for it. Now the FAA realizes that they have a problem here, and on March 17th of 2020, they issued a request for information entitled Low Altitude Manned Aviator Participation in Remote ID. And because they didn't put it in the Federal Register, it didn't get widely distributed. They only got 30 responses, and I'm proud to say I was one of them. And one of the comments that I put into the FAA is I told them that helicopters and aerial application pilots routinely operate in low altitude airspace, in other words, below 500 feet. And they feel they own this airspace. And convincing both sets of pilots that they should be concerned about drones is going to take a complete safety culture readjustment. And frankly, currently, helicopter and agricultural spray pilots especially expect drones to get out of their way. So the FAA at our last Drone Advisory Committee meeting, which was last Thursday, the FAA is asking us to work on this problem, and I'm very excited and looking forward to delving into this project and working on it. Now, some of the responsibilities and liability, I think that the expectation should be for all UAS to maintain, detect and avoid, and collision avoidance with all manned aircraft and other UAS at all times. And this is a position that's held by some of my fellow members on the Drone Advisory Committee, especially the airline groups. I think in controlled airspace where manned aircraft are required by regulations to squawk their position with a transponder or either transmit an ADS-B out code, and all UAS will be required or be equipped with remote ID. I think the UTM system should work very well, but when you get out into uncontrolled airspace where many manned aircraft are not squawking or talking, and cell coverage to access a USS through a network connection is spotty. I posed the following question. Is this collision avoidance expectation reasonable from a safety standpoint, a risk management perspective, and perhaps less importantly, a liability perspective? And when we talk about mitigating risk, the risk of an actual collision in Class G airspace because of the total expanse of airspace involved may be low, but the risk of a collision in Class G airspace because of the lack of mandatory communications between all manned and unmanned aircraft is much greater. Now, I understand this is a disruptive technology, and people can be afraid of change, but all you young pilots out there that are starting out in the helicopter world, I don't think you have that much to worry about in the near future. I think it's going to be a while before the skies over Dallas look like this artist's rendering in the picture below. So, like I say, have no fear. Keep working on your pilot's licenses and working on your career. And I think we'll be all right in the near term. Now, what is next for the industry? I got it on good authority that after remote ID comes out in December, then the next rule that will come out is for night flight, and then the FAA will issue a limited rule for flight over people, and that came from Mike O'Shea in the UAS office. And like I say, some companies are testing ground-based radars to do beyond visual line of sight, and others are testing acoustic systems. Now, as far as, I think the big key to this whole thing is going to be the detect and avoid and vehicle-to-vehicle systems. And like I say, the drone industry is feverishly working on this problem, and they're working on standards. There was a publication put out here recently where they discovered there's over 1,800 different standards already for UAS. And these three organizations here are among the main ones. Now, some of the issues with detect and avoid and vehicle-to-vehicle systems, especially if you mount these things on, and I think they're going to have to be mounted on the UAS for this whole thing to work. Your optical sensors, like your cameras, they don't work very well at night. And these are the ones that are currently employed on, like, say, the DJI Mavic models and the new Skydio 2, which I have on order. Passive thermal imaging or FLIR or near infrared sensors may be a solution. The Skydio X2, which is a commercial and law enforcement drone, is using GPS and magnetometer in all smartphones. They're in all smartphones. It's whenever you turn your phone, that's what tells the screen to turn, and they're using that for night flight. Active systems show a lot of promise, especially LiDAR. Believe it or not, I got a brochure from a company here a couple weeks ago that's making small LiDAR units that will fit on drones for collision avoidance, radar, radio frequency detection, and acoustic. But let's see. Now, communications, in the most recent FAA Reauthorization Act of 2018, it had about, I don't know, it was a lot of pages devoted to UAS integration into the National Airspace System. And they commissioned probably about 24 studies to be done and reported back to Congress, most of them within a year or 18 months. And here it is, it's almost 2 years, it's over 2 years later, and most of those are starting to trickle in now. And one of them was, they wanted the FCC, the FAA, and there was another organization involved in that too, that they wanted them to report back on the use of the vacant portions of C-band and L-band. Well, the C-band is 5030 to 5091 megahertz. And the FCC came back and said, yes, we're very on board with use of that portion of the spectrum, but they did not endorse the use of the L-band. That's 960 to 1164, stating it's basically too crowded now, because that's where your existing like ADS-B and TCAS and DME and a lot of aviation services are already located, and they're worried about interference. And they're even so worried, they're worried about it interfering with the GPS signals, which are just a little bit higher in the spectrum than that. Now, some of the licensed communication alternatives that have been put out there, and we've studied with the Drone Advisory Committee, the industry is finding that 4G LTE could be the answer for low altitude UAS communications. And I had a good authority from president of a company who builds these devices. He said 5G just will not work. It's ultra high frequency, microwave, strictly short range line of sight. And he said the signal can't switch fast enough between the towers. Satellite communications for medium and high altitude operations are probably just going to be a must. But man, the last time the FCC had a spectrum sale, they brought in billions of dollars. We're talking a huge amount of money is involved in trying to get these communications alternatives. Now, integrating UAS into public safety, there's almost 18,000 state and local agencies in the United States with 30,000 fire departments, but we only have about 235 manned aviation units. Public safety COAs and FAR Part 107 give those agencies that can't afford manned aircraft an inexpensive alternative to an aerial view, and for the first time. UASs can do approximately 30% of the jobs that manned aircraft can do. And for many agencies, this is plenty and really a blessing. They can look for missing kids, elderly, and do all these things that they weren't able to do before. They can get an aerial view, and it's really changing the face of police work all over the country. But the problem is the biggest cost involved in operating a UAS unit is personnel. And I've talked to several experts who believe that the biggest solution is going to be a drone in a box. In other words, you'll have these things, you'll have these drones in, like, say, a small hangar or in a box on rooftops around the city. And when a 911 call comes in, you launch the drone, it flies directly to the location, checks everything out, and it cuts down. I think Chula Vista, California is experimenting with this, and they've lowered their response times immensely. Now, persistent surveillance with drones is going to be out. And the reason why I say that, back in February of 2001, I actually traveled. I was involved in the Law Enforcement Thermographers Association at that time, and thermal imaging. We taught thermal imaging to police officers. And I went up to see this landmark case, U.S. versus Kylo, and it was the first thermal imaging case to get to the Supreme Court. And in this particular case, they used an AGIMA 210, which was basically the second generation handheld camera, highly pixelated. But as you can see, that's Kylo's triplex in the center. You see how much warmer it is. He had an indoor grow in there, like 700 plants. And the gentleman standing in the center there is Michael Drebin. He was the Deputy Solicitor General that argued the case for the United States. Now, this was a landmark decision because the court said it did not want to leave the homeowner at the mercy of advancing technology, including technology that could discern all human activity in the home. And the opinion, contrary to what Justice Rehnquist said during the oral arguments, he said we should not be creating future law in this case. We should be acting on the merits of the case. That's not what the Supreme Court did. They made new law in this case because they were so afraid of any type of technology like this being able to penetrate the home. They decided to just nip it in the bud right there. And they even admitted, they said, even though the AGIMA 210 is a relatively crude thermal imager, they said the rules must take into account a more sophisticated system that are already in use and development. Now, last week I sat in on a seminar put on by HAI. That's right. And there's a new thing you can get now from the FAA. It's called a Tactical Beyond Visual Line of Sight waiver, but you have to have a public safety COA to get this, and it's for use in times of extreme emergencies to safeguard human life. First responders require the capability to operate their unmanned aircraft beyond visual line. In other words, let's say you need to fly it to the other side of the building. You've got a fire and you want to check the back side of the building, but you're going to lose sight of the drone as it goes over the back of the building. Well, they're saying as long as you stay 50 feet above the structure and don't go beyond 1,500 feet, you can fly under this tactical beyond visual line of sight waiver. And I think it's a great idea, and I think there's going to be a lot of agencies out here and that are going to apply for this. And I know as soon as we get our drone program started here in Dallas, I'm still a reserve officer here on Dallas PD, and I'm going to help them set up a UAS unit. I'm sure we'll be applying for one of these also. Now, counter UAS concerns. Okay, there's over 200 systems on the market for detecting errant drones. But the problem is most of them use active systems like radio jamming or taking control of the drone, lasers, or employing munitions. And there's serious legal concerns in the United States for doing this, especially like violations of FCC rules and all kinds of other stuff. And as a matter of fact, there were 4 cabinet level agencies in DC that put out this advisory because apparently they're concerned that local governments and agencies are going to get themselves in trouble if they go and buy these systems. And this was put out in August of 2020. And it's an advisory on the application of federal laws to the acquisition and use of technology to detect and mitigate unmanned aircraft systems. The thing is, a lot of these systems are not licensed and they could be disruptive to other communications or to radar systems or whatever. So that's why they put this advisory out. And let's see, I think I've got just a little bit of time here left. Yeah, I've got a little bit of time here. Let me just go over a few things that are in the unmanned aerial mobility UAM, the UAM CONOPS. UAM is cooperative traffic management is conducted in compliance with a set of community developed and FAA approved community-based rules. In other words, these rules are going to be defined by industry to meet industry standards or FAA guidelines. Now there's going to be under UAM, there's going to be a fourth provider service. And they're called PSUs, or providers of service, and they will be utilized by operators, the commercial operators, to receive and exchange info during UAM operations. PSUs will be able to obtain UTM flight information via the UAS service suppliers network, and USS network will be able to obtain UAM flight info via the PSU network. So see, we're talking about down the road, after we get UTM up and going, then they're gonna try to incorporate this force service. And they also talk about something in this plan called demand capacity balancing. They're saying that intervention may be required to support operations as the number of UAM operations increase. Like I say, this UAM ConOps version 1 was the first attempt to taking a stab at this. So I'm sure the FAA is working on, just like they're working on version 3 of the UTM ConOps plan, I'm sure they're working on version 2. That's all I have right now. Let's open it up for questions.
Hi, Mark. This
Hey,
is
Tony.
Molinaro.
How are you?
Our regular moderator, Steve, is having some technical problems, so I'm going to take over the Q&A for him for a little while.
Okay, no problem. Great.
Oh, good, Mark. The first one, we have a few of them coming in. Could you explain the FAA's definition for low altitude? Is it below 400 feet?
I believe that is correct. Everything below 400 feet is their definition of low altitude airspace.
Okay. Here's one. How will the issue of noise affect the integration of unmanned aircraft systems into the NAS, the National Airspace System?
Well, that's a great question, because I mean, we have all these groups all over the country, and especially like Hawaii right now, that are trying to limit the number of helicopter like tour operators in Hawaii, and tour operators and number of operations in New York City. It's going to be a totally different sound signature. You get a machine like what is it? Amazon's machine weighs 88 pounds or something. Now, I can imagine my small Mavic drone, I can fly within 7 feet of a blue heron nest and not disturb the birds because it's so quiet. But the heavier you get, I've got a DJI S800 that's about 15 pounds with a good battery on it. And boy, that thing makes a racket. So this is going to be, like I say, it's going to be another disruptive technology that is really going to change the whole footprint. And is the public going to accept that? I don't know. It's going to be very interesting to watch that unfold when they start putting these things out there and they start flying them. It's going to be very interesting to see what happens.
Okay. Do any drone manufacturers put beacons on top of their drones?
I'm not sure. I think you can buy that as an option. I know on the DJI models, you can buy that as an option. And I think most of them now, like the more commercial versions, like for law enforcement, they are, I believe they are coming equipped with beacons on the top, because they know you're going to be flying them at night. So they might as well include them in there. And the rule is it has to be able to be seen for 3 miles, I think it's 3 statute miles, if I may be wrong.
Okay. This one is a tough one for you. You might not be able to answer this one.
Okay.
We'll see. If there's any kind of study, or if Pete, you've seen any statistics or anything out there of how many more accidents or mid-air collisions we may have when we get more and more drones out there? Or you can make your guess, I guess.
That's a good question, but no, I have not seen any studies on that. Most of the studies that I've read are on the number of UAS that are actually out there, which I question those figures because, there was a huge buying spree back in the 2013, 2014, 2015. It was like the thing to do, the thing to buy for Christmas. And I suspect that a lot of those drones were probably flown a couple times and they either crashed them or they, you know, it was a gift for a son or something, or a daughter, and they flew them a couple times and they got the neat video, and it's on a shelf somewhere in the closet. So really the good indicator right now is the number of remote pilot certificates that are out there, and the number of people who are actually renewing them, because it is a license that you have to renew every 2 years by taking a follow-on test. So that's one good indicator. And I don't know, we'll just have to see. I mean, it's still an emerging technology, and there's new uses for drones coming out just about every single day. And but no, I really haven't seen any. I really haven't seen any studies done on that.
Okay. Here's another one. Does remote ID apply to the drones that fall into the 0.55 pounds and below?
I guess we'll have to wait and see, but I don't think so. I don't think that's part of the plan, and what they call the 0.055. I don't believe they're going to be part of the remote ID plan. We'll just have to wait and see what the FAA comes out with in December.
This is going to ask for your personal opinion, I think.
Okay.
Should the responsibility of safety concerns for avoidance be that of the industry, and not that of this new industry, and not of the Part 135 operations, or not of GA? It's when you talked about who's really responsible. Is it equal responsibility?
I think it's going to boil down to whoever the operator is. Now, if that's the company, I think it's all going to fall back on the company, and they're going to have to make sure that they have qualified people that are monitoring all this stuff. And the responsibility is the buck's got to stop somewhere. And I don't think we're going to see that change in the aviation community, even with autonomy. There's still going to have to be a human that's going to have to be in charge of this stuff and responsible for what's going on.
Okay.
That's just my personal opinion.
Got time for one? I'm going to give you a nice softball question.
Okay, thank you.
I know there's good documents out there that you, in fact, were part of writing. Tell us what's out there that's been created that could help, especially our Rotorcraft folks, of what's going on with UAS, and some pointers about how they could use it to improve safety.
Oh,
the documents that you've put together.
Oh, the documents I put together. Well, I briefly mentioned the HSC 90 document. That was the, right now I'm participating in another HSC 70, which is trying to integrate or find ways to easier integrate SAS and stability augmentation and autopilots into single engine helicopters. So there's a lot of good stuff out there, and there was a bulletin that I put out back, let's see, I guess earlier this year, a 2-page bulletin, one on performance management and the difference between settling with insufficient power and vortex ring state. Now, the two are related, but they're different. Vortex ring state is an aerodynamic problem, and settling with insufficient power is exactly what it is. It's a power issue, and the settling with insufficient power and exceeding limitations accidents consistently since I've been on the USHST and analyzing these accidents, 1,000 accidents, almost 1,200 accidents now. It's 18% of our total accident rate, and that's pretty consistent over that whole time. 18% a year is, when you're coming in for approach, you run out of power and you smack into the ground, or you try to go over a mountain pass, you run out of power, you smack into the ground. It's 18% of all of our accidents, and a lot of these can be avoided if you just think about what you're doing and refer to the performance charts that are in your operator's manual.
Okay. All right, Mark, as always, excellent presentation. We appreciate it very, very much.
Well, thank you very much. And thanks,
All right.
to
Thanks,
everybody
Mark.
for tuning in today. Appreciate it.
All right. All right. Oh, and now we're ready for our final speaker of the day. It's Dr. Don Arendt. He's a senior technical advisor for safety management in the FAA's Flight Standards Service and one of our experts in aviation risk management. His topic focuses on safety culture. Don, it's all yours. I don't see him yet.
I don't either.
Well, as we wait for Don.
Well, Tony,
I
I was
see Phil-
told to be
I
on
see Phil
standby,
Dixon
so
on.
I'm on standby. We'll see what happens.
Yeah, we'll wait a little while.
Okay.
Well, as we're waiting for Don, some of the times all day we've been talking about the USHST. It's always good to go on that website, ushst.org. Lots of good stuff you can focus on to talk about if you're a private pilot, there's areas there for private pilots. If you're flying low altitude agriculture, there's areas there for you. All kinds of good stuff. If you're in HEMS, you can link in and get a lot of good stuff there. So it looks like we're going to go for Phil, if they're telling me, down at headquarters. And I'm going to present Phil Dixon instead.
Yes. Well, we'll
wait for a
see.
minute, Phil.
I can
Don't
wait
worry,
a minute
folks.
or two
Phil's
longer.
presentation is excellent. We're going to wait for
We'll give him a second
one more
or two.
minute on Don.
What's that again?
We're going to wait one more minute on Don, and if not, Phil, I'm going to go to you. But let's
All
wait.
right.
Let's give him a minute.
Gladly. I'll get set up in the meantime,
Okay,
just on the off chance. So
no problem. I was talking about the USHST website. There's also a Facebook page for USHST that every day you can get new stuff. They're part of the international group, which is the International Helicopter Safety Foundation. They have a website too for you want to learn what's going on also in Europe and Brazil and things like that. But you can get a lot of good stuff, and all of it's free. That's the other thing. Everything that's been put together that the FAA and the industry has worked on is all free of charge, especially for instructors. Sounds like maybe we have Don coming on now.
that works.
Wait, I don't see him yet. So, Phil, let's hold off.
I won't shut down just yet.
Like I said, all of it's free of charge, and if you're an instructor, it's great stuff to use. There's little videos there. You saw a lot of videos at the mealtime. There's a whole video page that anybody could use and download. There's small little videos you could use for your students, and great little two-piece materials for safety and instruction. Well, I'm still waiting for my folks to say yes or no, and I'm going to ask them to tell me now, one way or another.
Yeah, I'm not getting anything on my screen, except for Gene was telling me that to stand by.
The other folks out there that are making great stuff are the FAST team from the FAA. You'll be seeing new videos from them. Good safety stuff, all focused on helicopters. There's been a wonderful focus on helicopters over the past few years. So really good safety materials that people could use. FAST team does a good job. It's hard to do stuff face-to-face this year. But they're coming back with all kinds of good stuff once we get this whole year and everything going on over with.
Tony?
Yes. Oh, they've asked us to take a 5-minute break, and then Steve will be back with you. So we're going to take a 5-minute break right now, folks. And we don't know who we're getting yet, but we'll find out.
All righty. I'm standing by.
Okay. We can close our videos off.
Right, I will.
No, you should for now. Just close your video.
I'm working on it.
Phil, is that you, Sharon?
I was asked to perform a night vertical pickup from a submarine.
Phil?
On the sub was a sailor with appendicitis.
Not me.
Is that you sharing the screen?
Classic example.
No, that's not me.
Necessity. That is what the military defines as a mission.
FAA screen.
Okay. Yeah,
I can put the new video up though.
A military pilot declares
it's about 5 minutes long.
He or she can expect a
oh no, it's okay. Stand by.
returning home. I knew this full well, weighed all the parameters, and made the decision to proceed.
Is this the video for standby?
Forward to a military retirement in a new position. As part of the job, I recently spoke with survivors of civilian medical helicopter crashes. Their stories described a culture very different from the military. Even though they have their rules and launch criteria, they certainly aren't followed with the same rigidity. Story after story told of the 3 to go, 1 to say no rule being ignored without administrative repercussions. Then there were the stories where disregard of this rule led to fatal crashes. This culture is something I'm not used to. The rank structure in the military and consequences outside of physical exploration are always in the thought process when making cockpit decisions. This is one time where I believe the civilian world could learn something from the military. Follow your rules. They are there for a reason. Investigate when they are not followed. Before every flight, think about the consequences and if the mission is really worth it. Pilots, while the ultimate decision to launch and continue a flight is usually yours, don't be afraid to ask for and weigh your crew's input. So often we learn from failure, but it is much nicer to learn from success.
I'd like to welcome everybody back and see if we can stop the video. There we are. We're back. Sorry about the little hiccup there. I'll go ahead and now I guess there's a couple of hiccups. Me, I got knocked offline and it sounded like Don was having about the same problems I was trying to get in the Zoom room. But I'll go ahead and reintroduce Don. Our final speaker for the day is Dr. Don Arendt, Senior Technical Advisor for the Safety Management in the FAA's Flight Standards Service and one of our experts on aviation risk management. His topic focuses on safety culture. Don, all yours. And if you're on mute, Don.
Okay, it wasn't allowing me to unmute. Can you hear me now, Stephen?
Yeah, we have you now. We can hear you.
All right, let me select the right screen to share, if we can. Wait a minute, hang on just a second. I apologize for all the technical difficulties here.
It's like I know a lot up in Oklahoma going through ice storms right now, loss of power. Okay.
Let me get to the start here. I had all of this set up, and this is Proof positive why I've always been an old round dials guy. I don't trust automated things because I realize how long and how often I lose control of my PC. All right, now I'm trying to get back to, bear with me again,
Okay.
to where I can share the screen. Okay, has everybody got the screen there?
Yeah, there's the presentation's up.
All right.
PowerPoint.
And we need slideshow.
Yeah.
From the beginning. So if you've got the beginning on here.
Looks good.
Okay, we're ready to start. I always wanted to write a book that started within the beginning, but I never really had the cachet to do that. Here, you'll notice that the top here talks about safety management, and I'm not necessarily talking about safety management systems, even though that's pretty much my role in the FAA. But I have to remember, starting off with the title slide, safety management is something that you do, not something that you have there. And we talk about culture, and we talk about risk-based thinking here, and this is what I want to talk to throughout. We're going to talk a little bit about how cultures form, possibly some different ideas than what you might have seen and heard before, and possibly some differences in here. Also going to give you just a little bit of a sampler of risk management. Not going to be a tutorial on risk management, but just some words there, because that's the culture that we're really trying to do, one that instills risk-based thinking. As Dr. Sidney Decker said, we don't want to make people risk averse, we want to make them risk competent. Risk is there. How do we work with it? So we're going to talk about risk-based thinking throughout, from start to finish here, and how the culture reinforces it, but how cultures really work in organizations. Next, I've got a little slide, if you're seeing it with the tree on there. This is something that I unabashedly stole. I was told in graduate school, if you take people's stuff and sell it, it's called plagiarism. If you take a bunch of people's stuff, write their names down and sell it, it's called research. So I researched this from the ICAO safety management course, but I think it's relevant that safety culture and safety management are really flip sides of each other. And it's not a question of good, bad, there, not there. It's a question of how mature they are. So let's talk a little bit about organizational culture. You've probably heard a whole lot of this thing. You know, you've got to have a safety culture. Well, this sounds like it's kind of a new program. We're implementing it, we're establishing it, or whatever you see that kind of words. Well, why do I need one? I'm a good organization. I follow the rules. I was sharing this in the talk before. I'm good at the technical stuff. What's this safety culture stuff? Why do I need something there? But if so, how do I get one? How do I establish it? Where do I get it? How do I know if I'm there and have one of these things called the safety culture? Well, I'm going to tell you, if somebody says that you've got to have a safety culture, you can go home and say, you've got one. Every organization has a safety culture. And I would offer not to be caught up by the terms of good, bad, positive, this sort of thing, which you'll hear. They may all be relevant terms, but I don't necessarily think they add anything to the conversation. I heard something that was attributed to the press here sometime, and I'm going to apply this to pretty much every presentation I give. I'm not going to tell you what to think or what to do, but hopefully you can leave this presentation with something to think about there. And it's up to you to decide how you apply it. Every organization, though, and this was researched from a Dr. Jens Rasmussen, who unfortunately passed away about a year and a half ago there, but he was an engineer that did a lot with organizations. You've seen organizations and risk management. And you've probably seen the little diagram of the balance scales, production versus protection and whatnot, as being the things that organizations have to contend with. Rasmussen says there's actually three, and they're interactive. You can see the safety boundary up there and the safety margin, but real companies don't exist just to be safe. You can be safe by doing nothing. Stay on the ground all those helicopters, quit manufacturing stuff, and you're going to be safe. But you've got to go to work. So there's a workload down there. There's a workload that you have to provide useful goods or services to somebody. And of course, we in the FAA sometimes treat making money as almost as if it was evil intent. Real organizations have to make money in order to exist, in order to fund the workload that they do, their operations, in order to fund the safety efforts there. So it's a question of balancing in amongst these normal constraints. Certainly, both making money and making money for doing useful services are moot if you are not able to do that. Certainly to do that safely. But again, it's really a question of balancing this. So think about safety management as a handy term. I'm sorry, safety culture is kind of a handy term, a term that helps us to helps us to understand the areas of the area of the overall organization that's related to safety. Sorry, I had a momentary interruption here. But it's looking at safety in the context of what you do as an organization, whether you're a business organization, a service provider, a manufacturer, a maintainer, a trainer, or if you're a government organization, or if you're a nonprofit. It's all really the same. We all have these boundaries, and I call them mission, money, and safety. I know there's a sensitivity to the mission term. I had an Army background, so to me, it's just what you do, what you provide, the financial boundaries, and the safety boundary. All these drive your culture. I've also seen a lot of simplistic definitions of culture, but I like to talk about this one that's descriptive. It's written by Dr. Edgar Schein from MIT, who's been a very prolific culture researcher. Again, a organizational culture there. And look at these golden words that we have in here, and they're basically the things that define it. Shared basic assumptions. They're assumptions. They're things that people don't necessarily question, maybe can't even articulate. But they're the way we go about our work. They're learned, but they're learned largely by observation. They're learned by people living in the organization and seeing how their leadership responds, seeing how other members, their peers and subordinates do. And it's with adaptation. How do we adapt ourselves to our customers, to our legal, to our political, to our financial areas? So how does an organization adapt? And integration, how do they work together? How does it work internally? The cultures are learned by the group, but they learn by what's worked, what gets us through the day, what makes us a successful organization. And part of learning is it's taught to new members. Again, you were first starting out that said, this is the way things go on here, kid. Now, you might have did that, or you might have seen how he or she operated there. But that's how we teach our new members. It's mostly tacit. And this is a way from there that leads to those assumptions. That's the way they think, feel, and operate according to those things. Schein also says sometimes we mistake things. We look at these surface level things and say, I know all about their culture. Well, we can tell things about the culture by seeing the way people behave, but it doesn't necessarily get to the deeper levels because we don't know why. That's why it's hard to decipher. We have the espoused values. Everybody's seen these on the headquarters wall, I'm sure, of whatever organization you may have, of what sometimes it says, this is our culture, and there's a list of things there, or safety is job one, these sort of things. These are what Schein called the espoused values. These are things that might be written down or whatever have you. And they're not necessarily hoodwinking. They're necessarily, sometimes are things the organization does really reflect, wants to. They could be aspired values there. But again, it's things that we see pretty much on the surface and we can't tell. The thing that's hardest really to get at and really can't necessarily be done by surveys or anything other than in-depth moving around in the organization, there's what are those basic underlying assumptions, those things that are automatic, that are operated at a pretty much of a subconscious level. And how do they form? Well, every organization is a social system. And we have those psychological beliefs that we just talked about. We have the behaviors. Now, you notice it's a two-way arrow. And you notice, remember, we said we learn in the organization by seeing how things happen in the organization. We're socializing ourselves as a new member of the organization. And we see how others behave. We see what happens to people. We also see what our leadership says and what our leadership does. Look at their behavior. That may have us recalibrating. There's also the things that are the system and environment that we work in, the work structure, the work environment, the rules, what's the mission, what is the thing that we have to adapt to in order to provide those useful goods and services. So this is the way we operate in an organization. Again, it's a constantly changing thing, watching behaviors and behaving as a result there. Our attitudes, beliefs, and values that are reflected in our behavior. Of course, the system that we have set up that we work in sets some boundaries. All of these have an effect on the way we behave and the way we think. And what does this lead to in terms of safety management? This leads to something we call performance. The collective behaviors of the member of an organization is what we call performance. So let's talk about some aspects of safety culture. This came to us from the Europeans, but we're using it right now in a culture study within flight standards that are starting in order to evaluate culture, but culture with respect to safety performance. It's the only reason we really care about culture as a regulator is how does it affect overall performance? What can we expect an organization to do? Just like personality gives you some aspect on what a person that you deal with is going to do next, what their behaviors, what their responses to situations may be. The same as culture for an organization. And this was, again, developed by a European organization through quite a bit of study. One of the central things within each of these elements is information flow. And we're not talking about big data. We're talking about how verbal, nonverbal, written, non-written, automatic data systems and whatnot move information. How free is it within the organization? How many people guard the information? Knowledge is power. These sorts of things. And how much do they share information openly for us all to learn? So it starts out, of course, with a commitment to safety. The leadership, in particular, in the organization has to be committed. And this isn't, again, what they've got hanging on the wall, those espoused values. It's what do they demonstrate and what does their behavior look like? Remember, we talked about that. We were looking at what the management behaviors are, what the behaviors of our peers, the people who have been living in this organization for some time. So commitment is the way it starts. And of course, information is the lifeblood moving through this. We look over at justness, and justness says, how are people treated in the organization? This is often called just culture, which again has a life of itself, but it's part of a bigger whole. What leads to information should lead to awareness. Are we aware of what's going on? And down looking at behaviors. I know I'm jumping around the circle quite a bit. I apologize. Should have probably organized it a little bit differently there in the way I'm speaking, but hopefully you can see by this slide here. Then the organization has to be adaptable. One way to kill a reporting system is to burn the reporters. That's going to kill a reporting system really quickly. But the other one is if people just don't see that the organization's adaptable. If we report things, information is flowing, is the organization open to adapting to it? Remember that adaptation is part of the culture, but this is adaptation possibly in many cases from within the organization. What do the organization's members feel? What are they reporting? What are they telling our management? Is management receptive to it? And are they willing to invest in change? So these are what we call safety culture characteristics. Again, they're the attributes or personality traits that we have. Now, what is this result? What do these collective behaviors look like? when in the organization. So we said it results in it comes back to the behavior, the collective behavior. And when we talk about a culture, it's been described as a collective mindfulness. How do people tend to think alike? We talk about risk-based thinking here. And in risk-based thinking, that's a case that is everybody aware of risk there. One of the elements we saw just a minute ago in terms of safety culture characteristics. This came from some studies in what's called high reliability organizations. And don't treat reliability, the word reliability, in terms of the hardware reliability. We can have perfectly reliable hardware and still have accidents with it. How many times have you seen we wrecked a perfectly good aircraft over there in this organization? But how do people constantly think about risk? Well, it starts out with what we call a preoccupation with failure. Look at the small failures. Are people constantly aware of these things? And is this awareness flowing through the organization? Is the organization receptive for this information? In this case, there is no small stuff. The small stuff can lead to big stuff. So you're preoccupying with these little failures or these little anomalies there, and are we really aware of it? Reluctance to simplify. Now, in a world that oftentimes talks about keep it simple, stupid, you can make it too simple, and particularly at the outset. It doesn't say, well, we should delve ourselves into needless complexity, but it does say don't initially write things off. Oh, I've seen that before. How many times have we ever looked at a pull-down menu on a form, particularly those of you that have, let's say, reporting systems that are automated or any kind of analysis system? A pull-down menu, and you sit and struggle to try to put it into one of the areas in the pull-down menu. But from then on, that's all we know about it. So be sure that you don't oversimplify to point to where you're not aware of those small failures, those small things that can hurt you, because many times it's, as we say, the devil's in the details. So it doesn't say don't simplify, but simplify based on understanding of the situation. Don't try to do it too early. Sensitivity to operations, what's really going on out there. Now, one thing that we talk about in terms of audits tend to be, audit's a very good thing. Audit should be the process owner's way of stepping back and looking to see if there are things that are accumulating. Are there small failures that we've been overlooking here? But one of the things in audits is we audit to the design, we audit to the expectations of the design. And if we go out and make sure that when we do this, it's open, and I'll get to in just a minute the importance of employee reporting there in high reliability organizations, which again, I didn't say before. How do we define reliability? Just means consistently. High reliability means those organizations that are consistently able to operate safely in high-risk environments. Some of the initial studies back in the 80s done up here at Cal Berkeley, up north of me here, there were done on naval aviation. And if you think about it, what they do is totally whacked. You're taking off and landing on an airport that's too short for the airplanes that you're doing. So they're assisted by this big steam-powered thing there. You don't really have to carry maps if you don't want to, because the airport's not going to be in the same place where you left it. This got to have an ATP thing doesn't necessarily work, because a lot of the people that you're putting in these cockpits aren't old enough to have an ATP certificate and haven't got 1,500 hours yet. But we're doing all this stuff that's nuts, and we're doing it safely. And one of the things that is there is they understand the operation. They take a great deal of effort to understand what's really going on out there versus what we expected. It's been called work as done versus work as imagined. The other thing that we have, and I should have reversed these, apologize, but there's a commitment to resilience. Things happen. I think that's what the bumper sticker said, or something like that there. But we understand what can happen to us as much as we can, and be ready to ready to respond to it, ability to recover from these things. Hopefully, again, as if our awareness is looking at the small stuff, we'll be recovering from small stuff rather than big stuff. But even if the disasters happen, and it does occasionally to even the best, most risk competent organizations, what are you going to do about it? And the last thing, and this is one I probably should have put up with sensitivity and operations, is deference to expertise. Yeah, you always learn a lot about your presentations while you're giving them, even though the night before you thought they were perfect. But give deference to expertise there. Notice it says expertise, not experts, not the high-powered people with a briefcase from out of town, or the people with that are been given this designation, but the people that are doing the work. That's part of the sensitivity to operation and the preoccupation with failure. The people that are doing the work are the people that understand the work and the problems. And that's where, when I said about audits, we audit to what we think should be out there. It's imagined. We're looking for, is the system working as designed? The employee may be able to fill some gaps to you that say, it wasn't working the way you designed it. And don't ever say, don't bring me a problem unless you bring me a solution. We gave the employee a system. We told the employee how they had to operate that system. Now we're telling them, because they're finding out that they can't live with it and there's problems with it, that unless they can re-engineer our system, we're not interested in that. So please, if your employees are telling you things that with a suggestion for how to improve, we should listen to them. If your employees are telling you about problems with no idea how to improve it, but they know that it's a problem out there, we should also listen. So now we're going to talk about risk competence a little bit. I'll tell you a few things about risk management. I'm going to use a bow tie model. Some of us may be familiar with it. Some of us may not. Maybe it's a simple model here. And I'm sorry, I'm using a different version. Here, one thing I forgot. Here at the point that I should have mentioned is looking at how we rate the, save the bow tie for just a minute, we'll get there. How we look at cultures, and a lot of them use a lot of pejorative adjectives that, it's a good culture, it's a positive culture, or not, or pejorative adjectives that it's a lousy culture, or they don't have a culture. Well, look at it from the standpoint of maturity. Starting out organizations, in their cumulative, starting out an organization may be very reactive. The things that we say to a reactive organization, they're externally motivated. That is, either someone tells them something, someone delivers a bad audit result or a letter of concern from the FAA when we go out there, or they have an accident or an incident. So unless something happens that's really external from their internal operations here, they won't necessarily do things, and they're dependent on that. A bureaucratic organization tends to be a little bit a step above reactive, but they're basically usually a fairly reactive organization, but they're compartmentalized. They've got a lot of rules, and sometimes the rules and the way they're written take precedence over the practicality. Here, they're very much more organized, but still they're an organized reactive organization in many cases. A proactive organization, we look at it, is different. Now, one thing, they're internally motivated, and I said it was cumulative, so bureaucracies are necessary, particularly in larger organizations, in order to organize your activities, document things, have structured ways of doing things. So they're going to be reactive. Remember, we talked about resilience. If something happens, they're certainly going to respond to it. If some outside organization gives them information, they're going to treat that as a way to improve something. So they're all over that, but they're also internally motivated. You notice those traits we had at the high reliability organization? They're looking for these things all the time. They're tracking failures. They're looking at the way their operations are working, and are these operations drifting into ways that we don't want, or do we have processes or procedures that just aren't appropriate and aren't working and need to be engineered? They're on this all the time. So they're independent. They don't have to be told. They don't have to have an incident. They don't have to have a letter from their regulator. in order to make changes, in order to be adaptable that we had talked about there in the characteristics. And this is increasing maturity. I think it's much better to be able to describe how the organization is performing, how they're internally adapting, how they're internally integrating amongst themselves, and how mature they are along these scales of dependence and motivation than it is just to say they've got a positive culture and try to define some threshold for that. Something to think about. Now we'll be getting back to the bow tie model briefly in a moment. 4 questions for management, though. What do we have to be to answer as management in effective safety management? Well, these were written down by Bill Voss, who was an FAA employee and worked at ICAO, and in a hiatus from the FAA, worked as the CEO of the Flight Safety Foundation. And he said, at its root, there's questions you've got to answer. What could be the cause of your next accident? And remember, that's part of our preoccupation there. What could be the cause and our resilience? And how do you know this? What kind of safety intelligence do we have? Again, it could be a very sophisticated data system because we're a very sophisticated company, but it all could be just simple dialogue that we have. Remember, we said one of the characteristics and the major integrating characteristics here is how does information flow? How do we know these things here? And what can I do about it? Very simple. And is it working? I could almost put the how do you know this in all of these questions here, by the way, too, because again, it's all about information flow. Now let's talk about the bow tie model. I've been stumbling on that for a couple of slides here. And again, people like the bow tie model, people don't like the bow tie model, people don't know what they like or don't like about it. But remember here, it's a model, not a religion. So I'm going to use it as a way to illustrate here. Starting out with looking at risk management, what's the purpose of this? Are we doing change management? Are we looking ahead to a change that we haven't experienced yet, so we don't know what the operation looks like? Our sensitivity to operations doesn't kick in there because we haven't made that change there. So are we looking or evaluating a system or process design, proactive upfront risk management? What one researcher called doing a pre-mortem. What would it look like if it did go south on us? Here. We might be evaluating changes in the operational environment, things that we haven't brought about, but our operational environment has changed. Have the airport we're operating in change? Have regulations changed, and how do we respond to that? Or we may be looking at it as a look back, as a means of doing root cause analysis because something's happened. Say that's reactive. Reactive tends to be a bad word. So if you don't like reactive, just say responsive. It's a lot more proactive way to be reactive. But part of that resilience there, what are we going to do about the things that do happen and reduce the risk of the future? And then looking at the types of risk, are we talking about safety, or remember all the aspects, those 3 aspects that we looked at? Finance and operation. We have to keep those in that critical balance of being able to operate effectively, operate profitably, or operate at least within our resources, even NVO, non-governmental organizations, NGOs, or government organizations still have to operate within a budget. So there's different kinds of risk. There's the one that's traditionally we're talking about damage, fatalities, injuries, these sorts of things, but also that balance of looking at just your failure to meet objectives. So risk management can be used in a lot of different ways. And then of course we need to decide what's the scope of the risk management problem that we're doing, how big, how small, what's it to, and who's involved. Remember that deference to expertise. When you're doing risk management, learn from the people that are doing the work or going to do the work, who can tell you a lot of things about the hazards available. Now, this is those of you that are familiar with the bow tie model. This is one that you might have seen. Ignore those little numbers out to the side there. They're the ones that refer to sections in our ASMS rule. I left them in there though because some users of this presentation, if you see fit, it's open. I don't know what the distribution of presentations is going to be here, but mine are available if you're a taxpayer or an employee, so you already bought it. But at any rate, ignore that if you're not subject to our regulation. But the rest of it, bow ties usually have some kind of a failure or some kind of a disaster on the other side. But when you're doing risk management, particularly the upfront proactive risk management, try to do a no-fault bow tie first. Engineer success. What does success look like? What are the performance things that are needed, and what are those system things that are needed there? Remember, behaviors are driven in one respect by the system and environment that we set up. And in this stage, we don't have any pejorative adjectives. We're not talking about unsafe, insufficient, inadequate, these sort of things. Why? You're not engineering that. So what is it that you need in the procedures and the personnel, equipment, their training, their selection, the places we have them work, and the operating environment up at the top that we put them in? What does success look like? Because when we start looking at hazards, we're going to look at things that could cause a non-success. Now, we often look at hazards as a condition that could cause an accident there. And unfortunately, sometimes that gets us a little bit off track because the bow tie model there is going to show us that generally the condition that could foreseeably cause an accident doesn't do it directly. It doesn't say, here's a hazard, here's the big bang. It's in its effects on the system, in its effects on the success of the system. What could deteriorate in terms of those conditions that we put them in their facilities? Have we got people that don't have the competencies? Have we got too few people because we've expanded our operation? Now that workload area, we've expanded to the point now where our people are stretched thin. Those sorts of things that then could lead to a breakdown in the system and the accident. So understanding our operation up front there, that work as done or work as will be done, is very important in applying these definitions. So I'll leave it at that for now. And this is when we move that bow tie into an error there. What could be the breakdown in conditions? Remember, we just said a condition that could cause something way out there to the right, an ultimate outcome, but it causes it through a breakdown of the system. The system is no longer meeting its objectives there, and errors, failures, events occur. One thing I often point out to is human error is never a hazard. Human error is never a cause, but a description of that. So it's never way out there to the left. It sits in the middle. What caused that error or allowed that error to happen? And from there, there's a variety of outcomes. We can make a lot of errors. We can have lots of failures, and they're inconsequential. Sometimes whether or not it's a good, bad, or ugly outcome, you can color these any way that you want to, and your risk matrix there. But I live in Clint Eastwood's territory, so I just go back to good, bad, or ugly. Here, red, yellow, or green. That's enough for a first cut here. Many times the difference between an ugly outcome and an inconsequential outcome, frankly, is luck. So looking at these potential for the breakdowns of systems is where risk management is really at. Now to the risk matrix. Oftentimes we struggle when we use a risk matrix over whether it's the worst credible or most credible or what's the outcome that we're using. I encourage people to look at the range. Is there a big range of severity likelihood? Is the outcome possibly just luck and it may be different? Are there small factors, and this is why you don't want to oversimplify too soon? Are there small things that might give us a fairly inconsequential but maybe even embarrassing outcome there, but isn't likely to cause a major disaster? But there's another element out there that we must make sure that we don't gloss over up front. Is there a difference in the way that error plays out, in that the ability in some cases to recover from it without an accident there? If there's a large range, I often encourage people to just say, run the analysis with several different assumptions, run it several times. Think about if I really had a disastrous outcome versus I had something that damaged equipment, minor injuries, or was totally inconsequential. What's the difference in these scenarios? Also, is the risk matrix prescriptive or informative? That is it saying if it's in the red, it's absolutely unacceptable or can't be done? Or is it just to inform the decision maker in order to say it's high risk and that's the best we can do, so we've got to pay a lot of attention if we accept that risk? Think about how you use your risk matrix. Is it something that is a substitute for the decision making, or is it something that informs the decision maker? Remember, risk-based thinking. How do we think about these things? And we should always establish a rationale for what severity and likelihood we've chosen. That's part of the risk analysis portion there. Anytime we say it's going to be in the red or it's going to be in the yellow, we need to have a justification for that. Why is it that way? Not just we made up this risk matrix, jumped on it, and decided that the risk was unacceptable, acceptable with mitigation. You have to understand the risk very well there in order to decide why. So I can't tell you the number of manuals you see risk assessment, you know, put up first thing you see is the risk matrix with no process necessarily for determining why you've made those selections there. So look at that. Then we look at controls. We have proactive controls and reactive controls. Most regulations are proactive controls. That is, they prevent an error or failure or intended O2. Reactive controls are such things as post-maintenance inspections. We try to prevent errors or failures, but they're going to happen. People are doing work, sometimes with inadequate resources there, and we need to understand which things might be error-prone, but also which things might be, if the errors escape can lead to disastrous consequences there, or catastrophic consequences in our operation there. So sometimes reactive controls are necessary, but don't depend on them. Don't say we can do this, and if somebody makes an error, we can correct it. You can't always correct it. So proactive controls, something to understand the situation, are preferable, but in many cases, particularly in high consequence operations, reactive controls in addition are appropriate there. So things to think about there. And don't forget assurance. We tend to divide up the processes of SMS into safety risk management and safety assurance, and we draw bright, clear blocks around them and expect that there's something different. But they really are not. They're parts of the same whole. You're not really managing risk unless you assure that your risk controls are going to work for you. So make sure that we consider assurance when our assurance processes to ensure the effectiveness of the risk controls as part of our overall strategy. Management responsibility is key there. Our rule for management, that little squiggly line there, 5.23, we start in our FAA rule with saying that managers within the scope of their responsibility are supposed to identify the hazards there. They're supposed to make risk decisions. Can that operation go, or can that operation not go? Why? Because they're the people that have their hand on the switch, so to speak. They're the people that have control and day-to-day responsibility for the performance, the resource management, and the safety there. So we make sure that we start out with management responsibility, and they're responsible for assuring that the risk controls work. Why? Again, they're responsible for the workforce that's performing the areas where risk is occurring. But then we have processes for them. Are we looking at, are we monitoring on a day-to-day, job-by-job basis the performance of the organization? that the resources are adequate to perform it. Are the people there? Are the people skilled? Do they have the right information? We should step back and audit it. An audit shouldn't be something that's just to pass or fail. An audit should be something to give us information to evaluate performance, and an audit finding shouldn't be held against the manager as necessarily a bad thing if it's been the source of finding out and correcting things. So it should be used actively. When bad things happen, again, resilience. Think about what we're going to do. Investigation, and of course that employee reporting thing that we talked about before. At the end of it all, make sure that you're assessing: are your objectives being met? All of your objective as an organization. Are we able to perform our mission? Are we able to manage our resources? And are we able to do this safely? The other thing, here's a little thought process that also came from another place in MIT, Dr. Nancy Levison. Back to controls for a minute, and looking at your controls and your performance of your controls that we said is part of safety assurance. One way to think of them, we think of them as holes in Swiss cheese or barriers or what have you. But controls are really little processes in themselves. Think of them as the same thing that we do in a control process. So again, we have to have some kind of a mental model, some kind of an idea up there at the top of how we're controlling a process. There at the bottom, the throughput that we see there. Do we have some information to know what's going on in there? Is our mental model that we have up there at the top very clear? Do we understand what's going on? Are we sensitive to that operation? The work is done and possible emerging problems. And then over at the left, remember Voss saying, if you understand what could cause your accident, you understand what you're doing about it. Is it working properly? If it's not, you need to make a change. You need to be adaptable and change whatever your control process is. So think of your controls in terms of little processes and not necessarily holes in the Swiss cheese. Okay, now it shows you how, though, in risk-based thinking, back to it, this is something that I developed. It's very simple. Prints out on standard Avery business card stock. Risk-based thinking. Everything that's in our SMS rule is on the backs of these little cards. Now, I can't tell you, again, reluctance to simplify. We did talk about that. There's industrial strength problems that have industrial strength solutions or ways to address them. But it still boils down to some fairly basic questions here. What's going on in the operation? What could go wrong with the operation? How bad and how likely? Is it really something that we're going to worry about? Is whatever risk acceptable? And again, back to Voss's, what are we going to do about it? And then the bow tie model I include just as a way of organizing things. So remember, you can have very complex problems and you need complex solutions for them. The writer H.L. Mencken said for every complex question or every complex problem, there's a solution that's clear, simple, and wrong. So don't oversimplify it, but that's not what this little card is saying. It's all about the thinking, risk-based thinking. There is important. And I'm not going to go through this slide, but just to show you that it's true. Everything in our, or I'm going to assert that it's true, and that's my word, you got to take it for now, until you find it's wrong. But everything that's in the subpart on risk management and our rule is on this card. So you can't tell me that risk-based thinking is something that's tough, anything that is beyond all of us to do. You can put it in your wallet. Everything we've got there is in terms of thinking. It may require a great complex solution that's not wrong in order to address a complex problem. It may be a very simple day-to-day problem that we can, if we're thinking risk, or if we've got that collective mindfulness, and that's the culture where people are risk confident. People are thinking about risk as they go about their day-to-day jobs in the overall organizational structure that makes us successful and safe. And roll the wrong way here, lost control of the technology again. So in summary, remember, safety culture is a reflection of safety management. And we don't necessarily say high-level SMS management. Everybody manages some level of safety in what they do at any level in the organization. And safety culture is a reflection of that. Is that risk-based thinking? Is that collective mindfulness about risk endemic in the organization? Is that automatic? Is that what drives those deeper levels of culture at the subconscious level? Remember, the safety management systems empower them. Now, you can have a culture and attitude where you're willing to listen to your employees, but if you're a big organization and you have no system, no employee reporting system, you're not going to know. So the safety man, you're not going to know what goes on in your operation if you're not out there occasionally auditing and looking at it, et cetera there. So safety management systems provide the tools to empower the safety culture, but the safety management system that was check the box, put it on the shelf, yeah, it's up there on the top shelf, it's the one that says SMS on it there. Unless that safety culture is one of collective mindfulness on risk-based thinking, and I know I keep driving that in, then that safety management system is going to work. They're parts of the same whole. Remember that every organization has a safety culture. It's how it operates. It's not. Don't think of good, bad, pejorative terms like that, or it's positive or it's not, or even that I have one today and I didn't have one yesterday. Every organization has a safety culture, and trying to talk about rating it really isn't effective there. It's how mature it is and how it operates there. And remember, those of us that are regulators, I suspect we have a few people from the Friendly Aviation Association. That's what FAA stands for, isn't it? Out there, that the way we approach oversight is important. Remember that many organizations can be acceptable and still be very reactive. They're waiting for our input, and they have to be given very direct information, or they can't react. We can encourage them to grow and help them grow there, but understanding that they may require a different regulatory approach. The proactive organizations, remember, are innovative. They're able to devise their own solutions there. And if we're overly prescriptive with them, we may kill their motivation or at least disable it. So understanding the culture mutually between regulator and service provider is the way to build that growth and a better relationship. And now we're coming to the slide that everybody likes, because this says art is just about done talking. But I want you to look at that top there. This was that quote from Wilbur, the one that was rather phallically challenged, and not the one that had that cool looking mustache that was in all the photo ops there. Remember, he says careless and overconfidence are more dangerous than deliberately accepted risk. I treat that as some of the first vestiges of risk-based thinking that we see in aviation. Of course, it was easier for them to have collective mindfulness because there was only two of them out there. But I would attend that their ideas towards risk-based thinking were just as material to their success as their technical accomplishments, which were great. If you've ever really looked at what these weren't just a couple of ultralight guys coming out of the garage. They're very carefully thought through and very carefully accepted risk. So with that, I think I'm under time. So I'll open it up, Stephen, to any questions that you might have, or the group here might have. And if I don't have good answers, I'll just try to make something up here.
Well, thanks, Don. Yeah, it was a lot of information, safety management, risk management, safety culture for organizations, info. And I do have a number of questions, maybe about 9-10 minutes left. Go ahead and start with the first one, if it's okay with you.
Certainly, for me.
Okay.
It's your show from here, or yours and the participant show.
Oh, yeah, true. Well, the first question is, what's your advice to implement an SMS if you were a small operator, even a single operator?
Now, what I had a little data drop out on the first part of the question there.
Oh, no problem. What is your advice to implement an SMS if you're a small operator or even a single operator?
Yeah, it's a good question, and it's one that we're asked a lot. I myself have been involved in very small operations. Remember, again, it's the fact of are we getting information among the people? Are we getting information ourselves managing our operation? Any of these things, when we say some of these words like audit and investigation, there's kind of that fear factor that we're going to have to hire a bunch of people and have specialties and all that. Just going through your logbooks periodically, your aircraft logbook and your own logbook, looking for things that are impending, looking at things that might be those small failures that we're trying to prevent. We don't want to overfly our inspection periods. We don't want to overfly our duty time or our requirements for check rides or flight reviews or whatever is appropriate there. So we can all do these things. It's a question of looking at the things simply. Remember risk management. We're my little risk card there. We're about to make a change in the way we operate, in the change of our procedures or whatever have you. Just thinking through what could go wrong and what would it look like and how I can prevent it. So I would offer look at the processes from the standpoint at each one of these safety management system processes from the standpoint of, again, I'll go back to the mantra of risk-based thinking. What can my safety assurance tell me about what's going on, even in my own operation, whether it's one person? When I owned airplanes, I had to go through the books from time to time, make sure the ADs were up to speed or impending ones were done. I had to go through my own personal logbook, and it was just me flying, not mom or pop operations. So thinking about the risks that you're incurring at the time, whether it's a pre-flight risk assessment or you're planning for a new type of operation, you're getting into a different kind of aircraft that you didn't have before. That risk-based thinking and those processes, they're as simple as they may be or as complex as they need to be.
Thanks, Don. The next question I have is, what is the difference between the FAA's definition of hazard and ICAO's definition of hazard?
I'd say it's fairly minimal. Now the ICAO one is a little bit broader. Our original one, I could tell you now that the rule has been out for a few years, there's no ex parte things. If you look at the NPRM, ours was broader in the notice of proposed rulemaking. I'm sorry, that's same thing as an NPA for those of you that might be from Europe. The notice of proposed amendment to their rules. It was broader at the time, but when we got comments, there's a position where it said now you should limit the term hazard to the area of your authority. So that's more of its narrowness is more of an artifact of regulatory responsibility and authority than it is of hazard. Certainly, if you're an organization that has to manage the total organization, you have to look at OSHA things, you have to look at EPA things, you have to look at security. And I'd encourage you to use the same processes for all of those responsibilities that you might have. It's just that the FAA is written as narrow, a little bit narrower because of our responsibilities.
Sorry, I forgot to unmute. Thanks, Don. Let's see. Next question. As I mentioned earlier, it's a lot to digest. What is your advice on where I should start to build an SMS? Is there a good starting place for somebody just, I guess, build an SMS for their organization?
Well, I would normally, as the SMS guy, would direct you back to the regulation, whether it's incumbent upon you or not. Look particularly at the subparts on responsibilities, management responsibilities. If you're a very small organization, that's pretty clear. If you're your own self, it's pretty clear you're responsible for everything. there. But then look at the subparts that have safety risk management processes and safety assurance. They're very open. It's just a process for auditing. You determine what you need to audit, what might give you problems, what might go wrong in your processes, and look for them. Be attentive. Back to that safety culture thing that says, awareness of problems up front. Look at your particular problems. Look at if you're a growing company, look at how you're going to communicate with your employees. Now, if you're a very small organization, a standard employee reporting system might not work. It's not going to be confidential if you've got 4 or 5 people. Everybody's going to know who said. So establish some other way. It might be just through meetings, just focus groups. When I was chief instructor of a very small 141 school, we didn't have a formal reporting system, but we had a biweekly chat with the instructors, and part of our chat sessions there were looking at problem areas. What kind of problems have we had, and be open about them. So look at the processes that you have and think about your organization and how would you do that. I would say there's not much in there that can't be done if you think about how it would fit into your organizations. That gives you some kind of a guide.
Okay. Don, the next question is, what would be the elements that would support and or enable a predictive approach? Would the bow tie be helpful for that?
The bow tie could. Again, as Dr. Box had said, all models are wrong. There's things they'll do, there's things they won't do. It can be predictive in that if you think about it, all risk, whenever we say risk, it's inherently predictive because it says the likelihood of something that has some consequence, likelihood and severity. So think about what could go wrong and what's the possible likelihood of that happening. So they're all predictive. So the bow tie basically would start out either in the middle or over on the right side, preferably in the middle. If you say, well, this could happen in this operation. Again, thinking about what it's supposed to look like when it's successful, thinking about what could go wrong with it without regarding to what could go wrong at that time. Predictive then says, okay, from there, what's the chances that error could lead to something on the right-hand side? And then go backwards and say, okay, what could produce that error on the left side, and how do I prevent that error? If I'm looking at something that's already happened, like an accident, I'm already way out on the right side. It happened. Throw that away though, because that says a lot of that might be luck. But what caused that accident? What was the error, system breakdown, failure that would have caused it? And don't stop again at human error. That just describes what happened. Saying we know it's a human error. So saying human error was caused by human error is circular reasoning. What precipitated that? And what could a typical crew in the same situation done, whether it's a crew that's doing maintenance, training, flight operations, or whatever have you. So yes, it can help you organize your thinking, but again, don't treat it just as that, as a way to help organize that risk-based thinking, and don't get too rigorous with it. Don't get hung up with trying to fit which block do I fit it in or whatever have you. You're just really trying to understand either what could happen, and it may be in something you haven't done before, some kind of an operation that you're just undertaking, or it may be trying to predict in existing operations, where could it break down. You may be getting those little failure reports there, those things that happen. They haven't resulted in anything, but it's, oh boy, just another little change in this could have been a disaster. That's the kind of thinking that you want to do with it.
Okay. Thanks, Don. I think we have time for maybe one more question. Actually, I have a couple of questions pertaining to accountability, just cultures. So effective. With the safety culture or just culture, we talk about needing people to be open without fear of repercussion. But how's accountability defined in that kind of culture?
Yeah, oftentimes I've seen just cultures that are an algorithm, a flow chart, and they're almost to where we go through a flow chart and then the end block says, okay, now we can slam the guy. And you got the guy walking out of HR saying, I just got just cultured, see you in 3 days after my suspension's over. That's not what just culture is about. And accountability, I like to look at what Dr. Sidney Decker looks at. Accountability should be forward-looking accountability and not blame for what's happened in the past. Again, looking forward, being proactive about it, understanding what went on, understanding that human breakdown or human error. I've been involved since we've had the compliance philosophy in a couple of different discussions where when you got the airmen involved with it, you couldn't tell which side of the table was which. We all got comfortable with each other. We got to the point where we're trying to solve a problem. We're trying to solve a problem, not your problem that's happened in the past, but in the future. What can we do to improve things where it won't happen in the future? So Decker says it starts with giving account, in the word accountability, giving account of being free and open to say, this is what happened. This is how I thought my outcome was going to be successful. And I thought I had the ingredients for that. And it wasn't working for me, particularly when you're dealing with experienced employees. You may have a case where this person, if it failed for this person, that inexperienced employee, there's no hope of them avoiding this problem and possibly having a reactive control to come out of an error. So we've really got to fix this. So we need to learn from this person. So forward-looking accounting versus rearward-looking accountability is, I think, a much more proactive way to design it. True, there are times where sanctions and whatnot are certainly appropriate. Should be zero tolerance for some things, but I think that's really in the minority. Most people don't come to work to do a bad job. We've probably all heard that before. So think about forward-looking accountability and take blame out of the equation.
Thank you, Don. This brings us to the end of your session, the timeline for your session. We do appreciate taking the time today to present a lot of information about SMS and risk management. Thank you, Don.
Certainly, well, I appreciate the opportunity. Every time I have to convey something to a new group there, I learn something. And if you've got my contact information there, please give me feedback if you think so, even if you want to tell me I'm all wet. Wouldn't be the first time or the 100th time.
Thanks, Don. I know.
Yeah, thank you.
Appreciates it. Okay, well, everybody, that's it for day one. Thank you to the FAA Administrator, Steve Dixon, and to all our presenters. And I also want to say thank you to Tony Molinaro for stepping in when I had the connectivity issues. So thanks for saving me there, Tony. All the information they provide, excellent safety information. Now, stay with us tomorrow for day two, when experts from major rotorcraft manufacturers present maintenance safety information. And then just as a reminder, on Thursday, that day is going to be filled with safety materials for helicopter pilots. So until tomorrow, please fly safe. Thank you, everybody. And have a good rest of the day.